So, good morning to everybody, and I believe that yesterday you had a good learning day. Today morning we will start with the sustainable energy technologies, and the objective of this GIAN course is that to utilize the expertise or the knowledge which I can share with you with reference to sustainable energy systems, and then how we have to utilize the machine learning in managing, implementing, controlling sustainable energy technologies. Yesterday morning, I tried to give you one example of one of my project. That project, it was very interesting, and I believe that you might have enjoyed some description of that project, because that project is going to be very useful, especially taking into account our rural Indian conditions, because we know that in India there are a lot of people who are living below economic level and they do not have proper access to energy, and many people they are living in remote off grid areas, and it is our duty to help them to bring up back to the normal way. And for that we have seen through yesterday's project that how sustainable energy technologies can help them to have the energy access. Okay, so it means that that project what we discussed yesterday is going to contribute effectively on sustainable development goal 7, clean energy access for all. So today we will move forward, and today we will more focus on integration of renewable energy systems for hydrogen production. Okay, so this is a very hot topic at this moment around the world, and Indian government has also agreed that they want to be the leader in green hydrogen production. You might have observed through media, through technical news also, all leading industrialists, they are trying to use this green hydrogen as an energy carrier and to export green hydrogen in the form of green ammonia around the world. So this is a very interesting topic. So first I will share with you a very small example of one of the project which I did in 2006 and 7 while working at University of Jyväskylä, Finland. Yesterday I was mentioning that I was working as a research director at the University of Jyväskylä, Finland, and there my responsibility was to develop master's program in renewable energy with 3 components: education, research and demonstration. Education, all of us we know that we need to develop the courses and we have to teach to the young generation. Research also we know that we have to do the work with upcoming technology, but the key component of that project, it was demonstration. It means that we have to integrate the local community through this research demonstration project so that we can get the society integration in that. So with reference to that, you can see that in early 2006 and 7, I worked on this solar hydrogen energy system. So, how this solar hydrogen energy system it works? Okay. This is a very interesting topic. We know that, or yesterday also we discussed, and then when I will discuss all these things, then we will see that how we can use the machine learning for the controlling of such type of system. Yesterday we have seen that whenever we have the off-grid system or any renewable energy system which is going to have intermittent renewable energy sources. These intermittent renewable energy sources, for example, solar photovoltaic, wind turbine, etc., they are going to be connected within the distributed energy network or within the small power system network. Sometimes we will call it as a microgrid also. So, to overcome the intermittency of these renewable energy sources, in yesterday's lecture we had some discussion that we need to have appropriate energy storage. We know that battery bank can play the major role for the energy storage, but short term energy storage using battery bank is quite okay, but if we want to have the long term energy storage, then we need to utilize hydrogen as an energy carrier. I believe that many of you may be following the international development with reference to the upcoming technologies. You might have observed that all the leading countries, they are trying to move by utilizing hydrogen as an energy carrier, right. So, Indian government has also produced hydrogen economy document which says that India is planning to lead, okay, to produce the green hydrogen and to utilize that green hydrogen in making green ammonia and to supply it. So, how this green hydrogen is going to come, that we are going to discuss through this project which I did long back, let us say 20 years before. So, in this project, the idea was that when we have intermittent renewable energy sources, to overcome the intermittency of these renewable energy sources, we need to find out appropriate energy storage. To get this appropriate energy storage, either we can use the battery bank or we can use hydrogen as an energy carrier also. So, if suppose we are going to utilize hydrogen as an energy carrier, then how such system need to develop, okay. I was planning to use the document camera, but then I am thinking like if I use the document camera, then this picture will go out, okay. So, maybe I will try to use the board, okay, then it will be quite better, okay, because we do not have the dual or triple display, okay. So, maybe in the next lecture we will try to find out how we can do that one. So, now here if you see we have renewable energy sources, means sustainable energy sources. These sustainable energy sources output is going to be intermittent power versus time. So, this intermittency we need to overcome. To overcome this intermittency, we need the energy storage. And when we want to have this energy storage, what I mentioned that either we can use the battery bank or we can use hydrogen as an energy carrier also. Both energy storage are based on electrochemical energy conversion. Now, when we have to store the energy, so when we are getting the intermittent renewable energy, in this case it is the wind turbine and the solar photovoltaic system. So, this output which is intermittent in the nature, and sometime this system is going to be grid connected also. So, to overcome the intermittency of these sources with the objective of storing the energy in the form of electrolytic hydrogen, we need to have appropriate power conditioning devices here. So, these appropriate power conditioning devices, I believe that most of you are from the electronics background, am I right? Right. So, you know that how we can develop the power conditioning devices to integrate the wind turbine or the solar photovoltaic system together. If we consider the solar photovoltaic system here, so this power conditioning devices, it is going to be having the capability to extract the power at the maximum power point. Is it okay? I believe that you might have already studied about the maximum power point tracking of solar photovoltaic panels, and for that we need to develop the DC-DC converter. So, here you can see that within the renewable energy sources, when we have the solar photovoltaic system here, and we know that the output from this solar photovoltaic system is going to be depending on incident solar radiation under different conditions, right. So, our objective is that to operate the photovoltaic on this point, that is a maximum power point tracking mechanism. So, here I can say that it is a MPPT mechanism which is going to be based on DC-DC converter here. Okay. So, this DC-DC converter which is going to be required to integrate this solar photovoltaic system here is going to be very important. So, here you can see that when we are talking about sustainable energy technologies, how you can utilize your electronics background in developing a specific component which is required to integrate the solar photovoltaic system by using DC-DC converter to operate at the maximum power point. Okay. So, here we have that point. So, here you can see that how you can utilize your technical knowledge about that one. Similarly, for the wind turbine also, we know that wind turbine we need to connect here under the renewable energy sources here. So, this wind turbine is again depending on which type of generator we are using there. So, in small capacity condition, if we are not talking about very high capacity condition, so this may be 3-phase permanent magnet synchronous generator. Is it okay? So, those who are having some of the electrical engineering background or might have did some course on electrical machines may be aware about that one. Now, when we are talking about the wind turbine 3-phase permanent magnet synchronous generator, so how the output will be there? The output will be variable voltage, variable frequency. So this variable voltage, variable frequency, which we cannot feed into the system, because it is not at a proper reference level. So now here your electronics knowledge will come into picture when we have the output variable voltage, variable frequency. So basically that output is AC, and that AC we need to convert into the DC at appropriate voltage. So here you can utilize your electronics background on developing this power conditioning devices or understanding the operation of this power conditioning devices, which is required to connect the wind turbine with this system, right, by using this AC to DC converter. And then we know that similarly for the solar photovoltaic system, we have the maximum power point tracking mechanism. In the same case, we will also need to operate this system operating at point characteristics. So to turbine at the maximum power point, consider characteristics, have appropriate knowledge on developing that power conditioning device can help us operate turbine at the. It means that by utilizing the electronics background, you can operate the photovoltaic and the wind turbine, but the power and consume at the power, or to extract the maximum from this. Now, I will go into some detail sometime. After that, our objective is to store the energy in the form of electrolytic hydrogen, okay, because we want to integrate all sustainable energy charges together. That is the objective. So that's why GIAN, or the Government of India funding agency, approved. So now after this energy sources to operate them at the maximum point, appropriate devices, one device is for the wind solar photovoltaic system, operate at the maximum power point. Second, it is for the wind turbine. Here we have taken magnet synchronous output, that which we, for that we convert, and then when we have output, have the DC output as well as that DC output. That DC output, okay, very important, because you have to convert that energy electrolytic offshoot. Or the electrolysis, right? That's why I didn't mention about the thing. I mentioned output from that output have been provided. When we are providing that output, the electrolyzer, there are different type of electrolyzers are available. For example, alkaline electrolyzer, PAM electrolyzer, anion exchange, solid electrolyzer. Out of this electrolyzer, alkaline electrolyzer is a well established technology which have been used continuously from last 1 century, maybe I can say. So, we are in constant need of hydrogen, and there is going to be a big requirement of the hydrogen also. Okay. So, how it is going to be there, and why we need to have the hydrogen from the green or the clean energy sources. So, anyone can tell about this one? Because we are talking about to have sustainability within the system, and we want to reduce the greenhouse gas emission. Many developed countries, they have signed the agreement by 2050 they want to be the carbon neutral. India has also signed the agreement that by 2070 to be a carbon neutral. To become the carbon neutral, we have to reduce our dependency on hydrocarbon. Okay. So, at this moment, the hydrogen which we required for many applications is coming from natural gas reforming. Around or more than 95% hydrogen is coming from natural gas reforming. So, when we are doing the natural gas reforming, the CO2 is going to be emitted. So, it is not going to be the carbon neutral. And now, we have seen recently due to Russia-Ukraine war, there is a lot of geopolitical conflicts, especially with the energy supply or the natural gas supply. So, to avoid this geopolitical conflicts also, and to reduce the carbon emission, in place of hydrocarbon, we can use green hydrogen. So, the learning from this project is going to be very useful for understanding how the green hydrogen can be produced by using renewable energy sources. And you can see that I did this project in early 2000, which was funded by European Union Regional Development Fund in cooperation with regional industry at Finland. So, here when we are talking about this electrolyzer for producing the green hydrogen, we need to provide the DC supply. So, this DC supply from the wind turbine and the solar photovoltaic system, how we can get here, you can easily understand. But now, here considering the power electronics and the electronic component and the control system, we may need to control this power conditioning devices from the wind turbine as well as the solar photovoltaic system continuously by using PWM switching signals also. Okay. So, when we are using this PWM switching signals for controlling this AC to DC converter, DC DC converter, so we may need to develop this control algorithm based on the inputs which we are going to get from the wind turbine and the solar photovoltaic. It means that we should have the appropriate information about the incident wind speed on this wind turbine as well as information related to the incident to the solar photovoltaic solar radiation which are incident on the solar photovoltaic panels like that. Okay. So, now when we are providing this DC to the electrolyzer, when we are providing this DC power to the electrolyzer, and let us say in this case it was alkaline electrolyzer. So, alkaline electrolyzer always need constant power supply. It cannot operate under the intermittent power supply. That is why here either we may need to have another source to overcome the intermittency of this source. So, in this case the electric utility grid has been taken. So, when this alkaline electrolyzer it operates, right. So, it produces the green hydrogen because we are utilizing the green energy. So, when this hydrogen which is a byproduct from this electrolyzer and we are using alkaline electrolysis process. So, the hydrogen which we are going to get, it is already very pure, maybe 99.99% pure hydrogen. So, that pure hydrogen is basically as an energy carrier, and that hydrogen then going to be produced depending on the operating pressure of the electrolyzer. In this case it was the atmospheric pressure. So, here we are storing that hydrogen after doing the compression at a particular pressure. Is it okay? Are you able to understand? Now, here when we are talking about alkaline electrolysis process here, so this alkaline electrolysis process is again very important. I think most of you might have studied the engineering chemistry during your undergraduate courses also. We know that this alkaline electrochemical process needs proper operating temperature also, and of course, it will need proper electrolyte and as an input water also. So, when using that DC electrical energy which we received from this sustainable energy sources, we convert it into the hydrogen. Why we convert it into the hydrogen? Because hydrogen is having very high mass energy density compared to others. And when we are storing that energy in the form of hydrogen here, and this electrolyzer is producing the hydrogen at the atmospheric pressure, then we have to store that hydrogen either into the compressed form or metal hydride form or maybe in cryogenic form. Is it okay? So, if in most of the cases the hydrogen will be stored in the compressed form. Okay. We can store it into the metal hydride form maybe for the portable usage. If you want to store the hydrogen into the cryogenic form, then the temperature is going to be very low, around minus 273 degree centigrade. So, again we may need further energy for the cryogenic process also. So, compared to that, to store the energy in the form of compressed hydrogen is more practical, and for that the technology is available into the market. We can store that hydrogen up to 700 or 800 bar into the composite fiber tanks also. Okay. So, then when we are storing this energy here in the form of hydrogen, then we need to utilize it. So, in this case there were two options. One option was that to utilize that stored energy in the through the proton exchange membrane fuel cell for stationary application or maybe for automobile applications also. Okay. So, if we consider let us say stationary application, so on the top you can see that we have the electric load, and that electric load can be supplied by utilizing the electrical energy output from proton exchange membrane fuel cell. I believe that you may be aware that there are different type of fuel cells they are available, okay. But in this case, due to the purity of the hydrogen, proton exchange membrane cell, a membrane fuel cell, due to its lower capacity, can be a good candidate for stationary applications as well as small capacity automobile applications also. So, therefore, the stored energy in the form of electrolytic hydrogen have been utilized as a fuel to this proton exchange membrane fuel cell. When we are supplying that fuel to this proton exchange membrane fuel cell, so let us say this is a PAM fuel cell, and in this PAM fuel cell we are providing hydrogen as a fuel, and this hydrogen as a fuel, how we get? We got, let us say, as a green hydrogen, and this PAM fuel cell is again electrochemical device. To make the complete combustion or complete chemical process, we need to have oxidant also. So, this oxidant can be air or the oxygen also, and then this proton exchange membrane fuel cell, which is an electrochemical device, going to produce the DC electricity at a proper operating voltage, depending how many number of cells are there in the stack. So, when we are getting this DC output from this proton exchange membrane fuel cell, so this DC output is going to be at an appropriate voltage, which we cannot feed directly to any system. So, if that system is, let us say, DC system, so we may need here DC to DC converter, okay. And then if we have the AC load, then we need here DC to AC converter, and then we can fulfill this load. So, now here you can see that this proton exchange membrane fuel cell, in which we are utilizing hydrogen as a fuel, oxygen or air as the oxidant, and taking into account the operating condition of this fuel cell, we are producing the DC and putting as DC-DC converter, and then putting DC to AC converter, and we can supply the electrical load. So, here what I want to teach you, or what I want to share you the experience of working on this sustainable energy project, how we can integrate different sustainable energy technology for storing it in the form of electrolytic hydrogen, or maybe in short hydrogen as an energy carrier, and for that how we need to have different power conditioning devices integrated together. And then when we are going to get all this information and all these system components integrated together, then we are going to collect all the data here, and then I will explain you how we can use the machine learning techniques, right, for managing or controlling the operation of such type of system. Is it okay? Do you have any doubt or any question? Just feel free to ask, okay? So, here you can see when we are using the stored energy in the form of electrolytic hydrogen as a fuel to the proton exchange membrane fuel cell, we can supply to the stationary load, as well as we can supply it to the car also or automobile also. Okay. Now, here I will tell you, when I was working at University of Jyväskylä of Finland, so in cooperation with the local technical college, the local technical college, it is just like a polytechnic basically, they help in developing a single passenger car. They built this car specially for this project, okay, in which we are using this hydrogen as a fuel. You can see that in early 2006 we worked, in early 2000 we worked on that one. So, this hydrogen at one point we stored into the compressed form, but at the second point we want to utilize that hydrogen as a fuel in this single passenger car. So, in that case, case of the single passenger car, we used metal hydride hydrogen storage tank. Okay. So, those I think in your basic chemistry, engineering chemistry, you might have already studied about metal hydride conversion system for storing the hydrogen. Okay. So, in place of here hydrogen gas compression and storage, in the second phase we used metal hydride storage tank, and that metal hydride storage tank, right, because its capacity is, it is going to be very portable. So, it is quite easy that portable metal hydride tank to use as a fuel in this single passenger car. So, this single passenger car specially it was developed for this project, and in this metal hydride hydrogen storage tank have been used, and that hydrogen has been supplied to this proton exchange membrane fuel cell. And you know, then proton exchange membrane fuel cell, it was producing the DC electricity. So, the DC traction motor it has been used in this single passenger car. Okay. So, here I mean if you open your eyes and try to understand that how these different technologies can be integrated together with what objective? With the objective is that we are trying to reduce the carbon emission. We are trying to move towards the zero carbon society. So, here you can see all renewable energy sources, they are carbon neutral. We are storing that in the form of we are storing the energy in the form of hydrogen. We are utilizing that hydrogen for within the automobile sector. So, the emission from this hydrogen fueled car is going to be pure water, H2O, and that water quality is so pure we can even drink it. So, you see the overall objective is to make our system carbon neutral, and because I think all of you people are, including me, we are grown up and we always follow the news and everything, and technology development policies and everything. So, everywhere the objective is that we have to reduce the greenhouse gas emissions, and for that government they are developing different policies and like that. So, now hydrogen economy is also the key point for the discussion, and government is allocating lot of funding also for that one. So, here you can see that how the learning from this project can be utilized in achieving some of the objectives related to hydrogen economy. Okay. So, this is a very interesting project, and this project what I was mentioning that when I was working at University of Jyväskylä of Finland as a research director. So, this project it was under the category of demonstration of technology to the society, right. So, that the society should get integrated in the system. So, when we are producing the hydrogen and running the single passenger hydrogen fueled car within the community, okay. So, the people or the common public, they will get engaged with that one. Then we will get more public participation, public support, more funding also. And then this project also utilized for what purpose also? For education and research purpose also, because we have to train the next generation professionals also. So, many of the students, based on their different academic background and interest, they did their research work on different topics also. Some of the students, they did the work on electrolyzer characterization, modeling and analysis. Some of the students, they did the work on fuel cell characterization, modeling and analysis also. Some of the students who are having more electronics background, they worked on required power conditioning devices, how they operate, where we are going to have the fault, how we have to design and like that. And those who are having more interest in the control system, so of course, we need to have the complete control system here, and when we have the control system, we are going to collect all the operating data here. So, we need to have control and data acquisition system. So, depending on that, some students, they work on that also. So, here you can see that how the different disciplines are integrated together for this sustainable energy system with the focus on hydrogen as an energy carrier. Now, here I will tell you, this picture is maybe from 2007. Okay. In 2007, I organized international summer school in Finland, and many international students, they participated in this course, and we demonstrated this system also. And here in this picture, you can see all these are the international students from different European countries, and here I am in the white shirt who is demonstrating this single passenger car to the students also. So, now here I mean you can get the idea that, let us say, in the developed countries, how the education system work and how the students and the community, they get integrated with each other for improving their knowledge, learning on different technology. So, here based on your academic background, you may develop some proposal or maybe some research work or maybe project work with the help of your students on some of the components also. Now, here let us say I explained from the sustainable energy technology point of view. Now, we will come on the machine learning side. So, how do you think the machine learning techniques can be used for the autonomous operation of such type of system? Do you have any idea on that one? Yes, of course. So, then another thing which I can say that which I missed in this slide, but I am going to take that point in another slides at some point. So, here being in postgraduate level engineers, do you think any special thing is missing here? Yes, there is some special thing which have been missed in this project. What is that? Any idea? So, here what I want to tell you that wind turbine is there, solar photovoltaic panels are there, and of course, we have integrated the grid also, and you can see that every system components having different operational characteristics, correct? They are not having the same voltage current characteristics or any operational characteristics. To operate any system, we need to have some appropriate reference level. So, here in this project or in this block diagram, you might have observed that there is not any appropriate reference level, because when we want to operate such type of system autonomously using control system, machine learning, right? Now, in future most of the control system operation will be based on machine learning approach or physics based machine learning, that is much more appropriate word nowadays. So, for that we need some reference level. So, that reference level, do you think it is there in this project or in this diagram, let us say? There is not any reference level. Right. So, to operate such type of sustainable energy system in which every component is going to have very different operational characteristics, for that we need to have an appropriate reference level. So, without that going to be a very difficult. So, to understand that, we need to have some reference level, and on this reference level we have to see how the different components are going to be integrated. And I think most of you are from electronics background, what I understood, correct? Am I right? So, now if you have to utilize your electronics background, how you will help me on that one? Now, our objective with this GIAN course is to improve our knowledge, okay? To improve our GIAN, basically whatever we call it, right? And now for that we have to utilize your background, okay? And all of you are postgraduate, at least above postgraduate level, okay? So, now you have to help me how we will define a reference level and how this reference level we can use for controlling, okay, autonomous operation of the system. Okay. So, now maybe we will take coffee break, and after the coffee break maybe you can do some of your brainstorming and maybe come with some solution that how we have to define the reference level for such type of system, for what purpose? For the autonomous control. And how we can get that autonomous control? The data which we are controlling here, and doing the autonomous decision by using some physics based machine learning techniques. Okay? So, let us have a coffee break now, and after the coffee break we will again start. Okay? Hydrogen. While discussing, we observed that due to the different operational characteristics of the system components, we need to have appropriate power conditioning devices, and these appropriate power conditioning devices, of course, it is going to require your power electronics knowledge, and those components which we have seen, they need to operate autonomously. So, for that we will need appropriate control mechanism also, and to get that appropriate control mechanism and to have the autonomous operation, we will need continuous data monitoring and then using physics based machine learning. And before the break, I mentioned that the reference level which is required for operating such type of system was missing in that description. So, now I will try to explain you how that missing link of the reference can be avoided by using, let us say for example, DC microgrid architecture or DC bus level. For example, if we take your electric vehicle, within the electric vehicle you have so many different components. For example, electric motors, acceleration, deceleration, braking, so many different components are. So, we cannot, so there is some control mechanism and some reference level which helps to do the autonomous operation of all those components there. Similarly, when we are having this integrated sustainable hydrogen energy system, how we can include the reference level for monitoring, controlling and doing autonomous operation of these components which are having very different operational characteristics. Is it okay? So, now we will start with the step by step. We have this wind turbine here. We discussed that this wind turbine generally for the distributed case, it will be permanent magnet synchronous generator. So, this permanent magnet synchronous generator output is going to be variable voltage, variable frequency. V stands for voltage, F for frequency, and converting it into the appropriate DC level. So, this DC output is going to be there, and I mentioned that when we are converting that excess energy in the form of electrolytic hydrogen through electrolyzer and especially alkaline electrolyzer, okay, we need DC supply. So, let us say here we have alkaline electrolyzer. So, this alkaline, I hope that you are in a position to see from back side. Okay? So, this alkaline electrolyzer, due to its electrochemical reaction, needs DC supply. So, here we will need some power conditioning device, that is a DC-DC converter, to transfer the DC energy to the electrolyzer. For what purpose? To convert that excess electrical energy in the form of electrolytic hydrogen. Now, here we are going to have different DC voltage level, and here we may have different DC voltage level. So, let us say I am making one reference bus here. So, this reference bus, let us say I can call it as a DC bus. Okay. So, this DC bus in which we will monitor the voltage sustainability, we will monitor DC voltage sustainability. So, this DC voltage sustainability on the DC bus is going to be the key factor. So, the output from the wind turbine, which we converted from AC to DC and supplied it to the DC bus, okay, and this DC bus we are taking as a reference bus, and then we are supplying that DC power through this DC-DC converter to this alkaline electrolyzer. But here in this alkaline electrolyzer, our objective is to produce the hydrogen, which we produced here. Now, what we studied before the break, we have another source into account here. That another source, let us say the solar photovoltaic. We know that solar photovoltaic is a stationary DC output, but the same DC output which we cannot provide to the DC bus, because the DC bus voltage may be different than the voltage which might have been configured through the photovoltaic array also. So, it means that to operate this photovoltaic array, at maximum power point and to have the appropriate DC voltage here, we will need some DC-DC converter, and then that DC-DC converter is going to be connected to the DC bus. Okay. Now, here in this case, it is very clear that we are supplying the energy from these renewable energy sources via through the DC bus to the electrolyzer. Now, there may be another condition into account. We may need to utilize this hydrogen as a fuel for another applications also. So, let us say here we have some load also. If we have some load here, I am just giving very high level diagram, okay. We will discuss in detail with specific system components with specific control algorithm at later stage, okay. Do not worry about that. So, this load in most of our condition, it is going to be our AC load, okay, that which we cannot change, and here then we have DC bus. So, we may need to convert that DC into AC also. So, now here you can see that simultaneously we may have the load, simultaneously we may have the input from these renewable energy sources, but with what objective? With the objective of storing the energy in the form of green hydrogen. Now, here we are using renewable energy sources, there is no hydrocarbon. So, this hydrogen we will call it as a green hydrogen or the clean hydrogen. Okay. Now, to do this autonomous operation, okay, that was the objective. To do this autonomous operation, we need some control system here or controller here, because all the time continuously we cannot supply here, because we have the load here also, right. We have to do some analysis, or this controller or some decision maker has to take the decisions, right, for how much energy which we are transferring it to the electrolyzer with reference to the load, with reference to the available primary renewable energy sources are going to be the key factor. Now, this controller, what we are discussing here, it needs to get the continuous information of how much incident wind speed is there. Based on that incident wind speed, we can predict using technical characteristics of the wind turbine for estimating for the next few hours that how much energy is going to be available from the wind turbine. Similarly, from the photovoltaic also, we will need to estimate based on the incident solar radiation and then estimating how much photovoltaic power output is going to be there. Okay. So, here what we discussed in the last lecture or in the yesterday's class, that how we have to predict the photovoltaic array output using the incident solar radiation, and in that incident solar radiation, if you remember, we studied about or we just briefly discussed about direct radiation, diffuse radiation, ground reflected solar radiation, and that radiation has to be calculated on the panel of the photovoltaics at an appropriate tilt angle. So, that how you will do? We have to use some machine learning techniques for that one, physics based machine learning technique. It means that we need to utilize all those equations there as well as do the prediction analysis also, and then we have to include the technical characteristics of the photovoltaic, and that information will be required by the controller here. So, here you can see that how this sustainable AI means how we are going to use this machine learning for sustainable technology development. So, here you can see a typical a specific example. Okay. This is a very good project, and even if someone among you might have not completed the PhD also, can take forward for their PhD work also, because it is going to require lot of efforts, lot of knowledge and lot of integration of different system component operational characteristics and prediction techniques also. So, now here this controller, after getting the information from these different sources here, of course, it has to do the prediction also, right, and for this prediction you can use either machine learning techniques or conventional techniques also, any techniques you can use. Then at the same time we have to consider the load also. So, here this based on the historical data, we have to predict how much the load prediction is going to be there for next 1 hour or maybe 1 day ahead or maybe for few hours, right. That information will be required by this controller. After getting these information, okay, then the duty of this controller is that to develop some output signals. For what purpose? When we want to store or when we want to convert that excess energy with reference to this primary renewable energy sources, with reference to the load, for transferring it to the alkaline electrolyzer. Is it okay? But at the same time, we may need to consider the information at the reference level or at the reference bus energy level information. So, here you can see that the energy level at the DC bus, energy level at the DC bus is going to be changing. Why it is going to be changing? Because this is also intermittent, this is also intermittent, this is also intermittent, right. And due to that all intermittency, naturally the energy level is going to change. Are you able to follow? Because I am trying to give you in a very simple way, just like I mean to the audience they may not have as much technical in depth also. So, just to have more high level, but at the same time to create your interest in such type of work also. Okay. And then of course, you have to consider that how you can think carefully for using some tools, right, for developing control system for such type of system. Now, you might have got the idea that here when we are having intermittent inputs here, intermittent output here, due to that naturally this energy level is going to vary. So, even we are taking this reference DC bus on which this energy level is going to be the dynamic and going to change with reference to the time. So, that may impact the decision which the controller has to make. Correct, because here this is also dynamic, this is also dynamic, this is also dynamic. Due to that, this is also dynamic, and it is going to impact the output which controller has to make. So, to avoid that, on the reference bus or DC bus which we mentioned here, we may need to consider short term energy storage. So, this short term energy storage may help us in defining some levels of energy on this DC bus. So, this short term energy storage going to help for maintaining the sustainability of DC voltage on this DC bus. Based on that, then this controller can make the decision for transferring that excess energy with reference to the load to the electrolyzer. For what purpose? To produce the green hydrogen. Then to transfer that energy from the DC bus to the electrolyzer, even electrolyzer is the DC component, we need here DC-DC converter, boost converter. So, the controlling of the DC-DC converter, PWM switching signals is going to be decided by this controller, right. So, here you can understand that how your electronic engineering background is going to be useful for developing a typical case of green hydrogen energy system. Okay. So, it is very interesting. Now, the next question it comes, when we are supplying that energy to this alkaline electrolyzer, excess energy, but there may be some time we may have the deficit from these renewable energy sources. If suppose the nature is not supporting us, right, in that case, if we are not able to get the appropriate sustainable energy output from this primary renewable energy sources, and we have more load, then of course, we need to stop the operation of this alkaline electrolyzer. So, then this controller has to make the decision in stopping the operation of this alkaline electrolyzer, okay, because we are not getting sufficient energy, and we are talking about the green hydrogen energy system. So, we will come on that point after few minutes, but now when we are talking about the controller of the alkaline electrolyzer, that is a DC-DC converter, which and switching signals have been provided by this, let us say, main controller, maybe I should say, and here I should put some microcontroller. So, then main controller when sends the information to the microcontroller, and then this microcontroller controls the operation of the electrolyzer. So, this alkaline electrolyzer, depending its parameters, operational characteristics, etc., this hydrogen which will be produced here, right, it may be at atmospheric pressure. Okay. So, this atmospheric pressure hydrogen is not going to be good for storing. So, we may need to put the compressor for storing the hydrogen which have been produced by the alkaline electrolyzer, and then here you see for this compressor also we need energy, and that energy has to get from this sustainable energy sources. Then only we can say our system is based on sustainable energy technology. So, to get that energy for the compressor, then we have this reference DC level bus. We will take it from the reference DC level. It should come through the microcontroller, and energy will come like this, but its control will come through the microcontroller, because it is going to be a part of alkaline electrolysis system. So, now here you can see that for doing this complete operation, this is the main system component for making the decision, which is collecting all the data. And I think in the machine learning part you are going to study about the machine learning techniques, prediction techniques, regression, k-nearest neighbor equation, or using EML methods and so on and so forth, right. So, if you use any of the method, that is okay, but to make the decision here you say we need specific technical characteristics of alkaline electrolyzer, wind turbine, solar photovoltaic system, compressor also, because their energy consumption and energy production from the sources need to be more accurate here, need to be more accurate, not on the gray scale. So, we need more accurate prediction. So, to get the accurate prediction, we have to use physics based machine learning techniques. Okay? And then in that also we need to include the energy consumption of the compressor. Then accordingly we can estimate, how much after compressor, how much hydrogen is going to be produced. Is it okay? Now, when you will do some work on machine learning techniques, you have to consider this maybe as a one example. Is it okay? Now, here we are just focusing on green hydrogen production, and some of you may be aware that hydrogen is highly flammable also. Okay? Hydrogen is highly flammable. So, safety is again very important. Now, with reference to this all system components here, okay, we need to have the information how these different components they are operating at the same time to have information at this main controller about any leakage of the hydrogen. If there is any leakage of the hydrogen, complete system has to be stopped. Because we are engineer, we have to consider from the system engineering point of view, and safety should be on the top priority, because health and safety is on top priority. So, here we will have some sensors. So, this hydrogen detector sensors, it will be continuously monitored and the information will be taken by this controller. And if suppose there is any leakage of the hydrogen at any level, whether at the alkaline electrolyzer production level, maybe at the compressor level, or maybe at the storing level, So, all those information basically through this hydrogen detector sensors need to be integrated in this controller for making the decision for stopping the operation of the system completely. Is it okay? Now, coming back to this point here, we have this hydrogen production or compressed form of the hydrogen, and we are talking about the green hydrogen. Renewable energy output is going to be the intermittent, we need to predict. So, here this hydrogen production prediction is going to be very important from the market supply point of view, because we have to see that how this hydrogen is going to be supplied to the market and at what rate and at what time. Because what we studied earlier, this hydrogen can be used in many sectors. For example, in the process industries, for example, steel industries, we need continuous hydrogen here. Okay. And this hydrogen consumption at this moment, it is coming by natural gas reforming, around 95% hydrogen. But we are moving towards the green hydrogen system, and green hydrogen system means we are utilizing the renewable energy sources. So, the prediction of this hydrogen is very important for the steel production also. So, here you can see that how your machine learning techniques or prediction techniques can be utilized for the supply of sustainable hydrogen for the steel production also. Okay. But now, in my opinion, most of the demand is going to come through ammonia. So, this ammonia we need for fertilizers. So, for fertilizer to have this sustainable ammonia, and we know that for a particular, during a particular season, how much fertilizer consumption is going to be there, right? How much market demand is going to be there, and whether we are is in a position to utilize this green hydrogen, is in a position to make it self-sustainable or not. So, for that, then you have to use some prediction techniques. Without that, then we cannot say that we are going to get the green ammonia. And then this green ammonia when we are utilizing here into the fertilizer, right, then at the same time this ammonia can be used as a carrier from one point to another point, because the transportation of ammonia from one point to another point is a well established technology and commercially available. Okay. So, coming back to the key point here, on this system, like how do you think you can utilize your academic background for some of the part of this system? I know that some of you may be very good in DC-DC converter also, correct? Because you are from the electronics background, many of you? No? Okay. So, some of you may be from the electrical engineering background, some of you may be computer engineering background, yes. So, in computer engineering always we need some mathematics, okay. Without mathematics we cannot do anything, okay. So, let us say if you are having the computer engineering background and your task is to design the controller here or to design the algorithm here, okay. Let us say algorithm is much better word, that how you will design that algorithm. Now, my question is that how you will design the algorithm. Because algorithm development is the key thing, let us say. How you will define or how you will make the flow chart, let us say, of this system, and that is going to be used in the main controller, let us say. Yes. Yes. So, you said that let us say here we have this main component. So, here the some of the inputs will be there. So, what input you said first? Yes. Yeah, carry on, carry on. I will explain you. Don't worry. Yeah, carry on, carry on. I will rectify it. Don't worry. Yes. Yes. Mm-hmm. Any other person who can provide some input? I will explain you, don't worry. Just your guess, because all of you are the postgraduate engineers now. Any idea? Don't be shy, okay? You have to be reciprocative also, right? Because you have to also provide your thoughts to me, because I am always giving my thoughts to you. So, it is also always good to have your inputs to me also, okay? So, then I can see that yes, you are in a position to understand some of the part of this sustainable energy system components, and then how we can use that learning. Okay. So, what she told to us, that is a really important point, and I will make it more systematic, that one. Okay. What she told, that is a really very good guess. We have wind turbine solar photovoltaic, and we have to develop the algorithm for the operation. This solar photovoltaic and wind turbine, they are our primary inputs, and of course we have the load also, okay. And then in between we have some excess energy from these primary sources with reference to the load, and that we want to store in the form of hydrogen. When we are talking about the inputs, so this input, let us say this input is not starting. Good. So, when we have this input, that is a time dependent. Here we have the prediction of the wind speed, correct? We will get the prediction of the wind speed. Based on this wind speed prediction, considering technical characteristics of the wind turbine, we are going to get the power output prediction from the wind turbine. There are a lot of models, they are available even in the MATLAB Simulink also. We can provide the input of the wind turbine, and providing the characteristics of the wind turbine, we will get the power output. In this case, our wind turbine is variable voltage, variable frequency, but that which you cannot connect here. So, we have the DC output here which we connect here. But now main input is this. This we will take as a complete one model here, and we got the P output here. Similarly, here we have the solar radiation input. Okay, there are many models or lot of research work have been done here and widely available. Based on that, we can get the PV output production, in which of course we have to consider the technical characteristics of the photovoltaic system also. Now, this output from photovoltaic and the wind turbine, that is for us the input to this controller. But at the same time, we are having the load also. That load is dynamic, okay, and using some prediction techniques. I will share some models with you also and some papers also, how we can do the predictions of the load, not only with the active power, but with the reactive power also. All that work I have done. So, let us say that prediction is there, that model is there. So, that input is also going to be required, and that input is going to help us in getting the difference of the input power, output power, and that difference we need to provide to the electrolyzer, and then the electrolyzer characteristics will come into account, and we will get the hydrogen prediction also. But now, when we are getting this difference here and here, we are going to have the energy level at the DC bus, and this energy level at the DC bus due to these changes is going to be also the dynamic into the nature, and that we have to make, or that we have to keep in sustainable level also, right. We cannot have there should be some minimum maximum level of the energy at the DC bus, which we need to define in our algorithm. That is a minimum maximum, and then with what objective? To produce maximum hydrogen. With our objective is going to be how much hydrogen maximum is going to be there. But here we have the input variables, right. This is also variable, this is also variable basically, and that we are going to predict with reference to the time, we can say, and with reference to the time, then energy level is also going to be changed. So, on this energy level at the DC bus, we need to define minimum and maximum level also. If it is going below minimum level, not good, and our maximum level, then of course, we have to pump more and more energy to the electrolyzer to put it back to the below the maximum level, and overall maximizing the hydrogen. And as a constant, or as a constant to stop this system, right, we need to put as an input, if suppose there is any leakage of the system, system should be stopped. So, can you develop one algorithm like this? If I give this task, let us say for doing exercise for half an hour, will you be in a position to develop one algorithm or the flow chart for this process? So, okay. So, do not worry, not need to develop now, but whenever you go back to your home and to your work back, you can think like how we can develop that one. Okay. But now you got the idea that if suppose we need to utilize our control system knowledge, algorithm knowledge, electronics knowledge, electrochemical energy conversion knowledge, renewable energy technology knowledge, how we have to integrate together. Then only we can achieve this sustainable hydrogen production. Let us say some of you having computer engineering background, but when they want to develop this algorithm, right, and here you have seen that electrolyzer is one major component here. So, you need to have the input from the electrochemical engineer also, who is very good in building the model or developing the model based on the electrochemical reactions also, because without that you cannot build the model. You need all mathematical equations for that one. And then another thing which you might have seen, that not only that, but we have compressor also there, right. So, compressor energy consumption is going to be there. So, that is also going to impact, the energy level here, right. If suppose someone among you may be having mechanical engineering background, let us say, may be in a position to develop the model for the energy consumption of the compressor with reference to this case, right. That also you will need as an input parameter there. So, not only alone the computer engineer can develop the algorithm, but going to require the domain knowledge expertise for integrating all these system components. Similarly, here we have taken the wind turbine and solar photovoltaic also. So, for wind turbine also, now with reference to the change in the technologies, different type of wind turbines they are coming into the market, like doubly fed induction generator, coupled wind turbine, permanent magnet synchronous generator, coupled wind turbine, and now this generator are having the capacity of 3 megawatt, 4 megawatt, 5 megawatt, offshore installation, onshore installation, location, ground conditions, then based on the input data of the wind speed at that particular location, taking into account the operational characteristics of that generator, taking into account power versus speed characteristics, when it is going to be operating at the maximum power point, constant power supply, constant CP, right. All those factors then going to be required here in developing your algorithm for the wind turbine, because in that algorithm wind turbine input is going to be the wind turbine output is going to be as a main factor, because that is a primary supply, and of course the wind speed prediction is going to be required. So, now here you say, if you want to utilize your knowledge and your expertise with reference to the sustainable technology development, how you have to work in integrated manner. You cannot work alone. That is the beauty of multidiscipline engineering approach. So, in your PhD project, if you are planning to do, always consider to have multidiscipline inputs with only one single domain input. The output may not be sustainable or may not be at useful for such type of projects. Is it okay? I hope that you learn some new thing, because that is the main objective here, okay? Because we cannot have the knowledge of all the, if someone asks me, let's say, for a embedded system, so I don't have any expertise, or I don't have not that much knowledge about that one, so it is just like that, okay? But now, with reference to the objective of this GIAN course, I am trying my best to share my experience of more than 3 decades of working on these projects, and I want to help you so that you can become a good professional engineers, good global citizens, and contribute effectively by using your technical knowledge for the sustainable development of the society. Because here you see, I mean, we are talking about green hydrogen system. Of course, lot of economics are involved, lot of industries are involved, and many things are there. Of course, everyone is making the profit, but overall we are looking that we are reducing the CO2 emission, and reduction of the CO2 emission is required for our survival also. So, our objective is to have better life for us and for our next generation, and it will be possible when we are going to do, or when we are going to do the practices of sustainability. Then only our next generation, they can survive very good in this, on this earth basically, right. So, we have to see that how we are going to get the knowledge and how we are going to teach our students also, right, so that they can also contribute effectively for our society. So, shall I stop here today? What is the lunch time now? It's lunchtime now? Okay, good. So I have a lot of materials we will share. So, and some of maybe if I'm not able to share all the materials together, I will share you the links of the published PhD thesis of my candidates, research papers, and depending on your interest, background, okay, you can refer some of them because we know that we have limited time and you cannot read all the materials, but you can select anyone which is of your interest, and I will be very happy to guide you, to help you as per my capacity or availability basically. Okay. So I hope you will be having good lunch now. Good, thank you.
No? Okay. Okay now? No, it's fine. Okay. So, according to renewable energy system, the technologies and methods that is required, that is used to generate the energy from various renewable sources. So, as of now we have seen various sources are there. So, these are the natural sources are sustainable over the time. That means with respect to time we are going to find out the sources which will be utilized once sources are not available, like whatever the non-renewable energy resources are there like a petrol, diesel and other things. So, what we will do? So, we should be ready. So, how system will sustain with respect to energy resources are available. So, these systems are harness and natural processes such as we are going to utilize sunlight, we are going to utilize wind, we are going to utilize water because these are the available resources with us, flow and geothermal heat. These all processes are required to produce the electricity, and we want electricity. So, we want the power, how power will be generated, and this will be the utilization format in terms of energy. So, we are getting the energy from various sources. These are the various type of renewable energies are available. So, hydropower related to water, solar energy with respect to light, sunlight and wind energy with respect to wind. So likewise geothermal energy, all these are the sources available with us that will create the electricity, and it will be in the form of energy. So related to renewable energy sources, you may get it, this is the tree structure. In this tree structure you may get it hydropower, solar energy, biomass and wind energy, and related to one more energy, that is geothermal energy. So related all these sources, how we can you can utilize. So here we can get it, that is dam. So in the dam we are going to utilize the various techniques, then pump storage, diversion, and here this solar energy related to concentrating solar power and solar photovoltaic and solar thermal. These are the two sources. Biomass related to landfill and biogas and solid waste. So we are going to utilize various solid waste to generate in terms of wood and agriculture, or as well as alcohol fuels. Related to wind energy, onshore and offshore, these are the sources we are going to create. And geothermal, flash stream with respect to dry stream or binary cycle. So this is the type of resources. In terms of this tree structure we may get it, how the utilization, that means globally how renewable electricity generations are going to work from 2008 to now 2018. This is the graph will be available. So these are shares of renewable energy resources. So related to 2008 it was 1060 in terms of gigawatt, and last now 2378. So like with respect to here how this energy resources generation is increasing exponentially. This is the renewable electricity generation globally, how these resources are able to manage, and what is the main reason? Because increment in the popularity of renewable energy resources. That means if you will see, there are many universities, there are many industry, and there are many, that means countries, they started to initiate it. That means the global initiation was the main reason towards the this renewable energy resources, and how we are going to develop to make the system sustainable. So our concern is sustainable development. So sustainable development, I said yesterday, we want to get power. Without power we cannot survive. Everywhere we want power. Our system will work with power. Our mobile phone, our laptop, tablet needs power. So without power your all system will fail. If one day electricity won't be there, what you will do? You cannot manage. So we have to work for upcoming years, what will be the situation will come. Okay. So anything may come, like a pandemic came 2019, we were not aware. So anytime any situation may occur, we should be ready. So that's a reason from 2018-19 onwards, there is a development started related to sustainable energy development. So in 2018, global RES power generation increased by 181 gigawatt with renewable energy. That is expectation related to amount of 26% of global power generation by the end of these years. So solar photovoltaic lead the growth, and we are comprising 50% of new capacity, almost 100 gigawatt, followed by the wind 28 and hydropower 11%. That is increment given. So key trends, over 19 nations, they generated at least 1 gigawatt renewable electricity by 2070, and with 30 nations exceeding 10. So related to solar photovoltaic, they show the highest growth. That means the rate increased from 2013 to 18, although hydropower remained the largest contributor in renewable electricity. That means almost 48% share by 2018. And from 2018, the wind had 591 gigawatt of capacity, PV had 505 gigawatt, biopower had 130, and geothermal had 13.3. So top countries, they installed this capacity by 2018 were lead China 30%, followed by USA, then Brazil, and then Germany. So already from the globally, they already started to work related to this electricity generations. So what are the trends are there in terms of energy generation from 2010 to 2020? So 2010 to 2020, whatever the renewable energy resources were available, that usage has increased, that we have seen the experience significant growth through this graph, rising from 2098 terawatt to 7627 according to the IEA 2021 Global Energy Review report. So according to that report, this energy information has written. So hydropower is one of the key renewable energy trend. Its continued contribution was started, largest portion of the global energy through the growth rate is lowest. Solar energy, another second version which shows the significant upward due to the advancement in energy conservation efficiency. Wind energy also third demonstrated steady and notable growth. And fourth is the bioenergy and geothermal. That is the minimum contributions due to the suitable locations, because we want limited locations are there, we want perfect location, as well as production process is very complex. Because of this reason, it work as a fourth level. So country who are working related to first hydropower, that means with water they are using for generation of electricity. So in India there are many dams are there. So how technology advancements are there in terms of enable to this renewable irrigations. So renewable irrigations basically is very important. Why? Because we are able to improve the efficiency, because solar power, solar panels as we are using, and there is a government also giving some subsidy related to solar panel who are installing the solar panel. Government is providing subsidy to them to give the encouragement related to solar. So solar panel efficiency has increased significantly. This reduce the land usage and maximize the energy output, as well as larger turbines. That is another efficiency, that point will be there. So wind turbine which are using for technology aspects, so advancements offer the higher capacity factors, or related to towers capture the stronger winds. The towers which are using, they will capture the stronger winds. So winds will run as per that, they have to capture. And the smart grid, that is the third aspect, how we are going to enable the renewable energy resources. So smart grid, that technology has utilized particularly balance supply and demand effectively. So whatever the demand will be there and whatever the supply will be required. So as per that, power generations, power transmission and power delivery, these are the three aspects are there. So in that they are enabling better integrations of variable sources. So whatever the variable sources are there, they are providing the better integrations. So as per that, smart grid environment, how smart grids are working, what are the systems are there. So if you see the smart grid system, we all are having all renewable energy resources. This is the area where the dams are there, hydroelectricity will be generated, and how these are the wind turbines are available. This is the particular fuel power phase are there, this is the nuclear plants are there, and particularly this power, that is photovoltaic solar cell will be available. This is the where we are going to provide the residential area, commercial area, industrial area, and this is the electric vehicles. So nowadays you have seen the electrical vehicle trends has increased. From the past 5 years, people have started to use electrical vehicle. So that case we are going to reduce the cost for the fuel which are very costly in terms of petrol, in terms of diesel. So as we have seen it must be reliable also. So electric vehicles require related to smart grid environment. So this is the complete smart grid environment will be there. That is the one directional energy flow and bidirectional energy flow. So we can see one direction, this is bidirectional, this is one directional, this is one directional, this is bidirectional, one directional, this is bidirectional, this is the one directional, one directional. So likewise, when we will see the smart grid environment, overview of the smart grid environment with respect to energy management system. So a smart grid network architecture we need to understand. It will be comprised in terms of layer. That means multiple layers are there. If you see the first layer, the contribution will be security concern, because security is our concern which safeguard the communication about the data and it travel across the network, because data is traveling through the network, and how we can provide the security that to protect the data. So that is our requirement. So network management, that part is very important. Network management is responsible for maintaining the secure communication. So secure communications and to the next layer. So data will transfer from one layer to another layer. You have to maintain the security. So security mechanism is very important to ensure that quality standard as we meet or not. And the finally, that means we are going to provide the standard calls are there. So that standard calls for a chain of area of network, how the area of network is working to superimpose this power zones. So we may get it the chain of area network, connect all gadgets in terms of smart grid network. That means we have the renewable energy sources we are going to generate. So generation, then transmission and particular distribution. So here generation will generate the energy with respect to various renewable energy resources, and then after that, so this is the generation part. This is the transmission and distribution part, how the data will be identified. That means transmission, automated transmission will take place, maintaining and control automations, and then we are going to provide the intelligent subsystem. That means it will take identification by AI or various intelligent techniques that will identify to provide the energy. This is a storage, that is the energy storage and DG, and this is the distribution that also will take place automated, and now we are user, as I said. So after that we have to provide delivery. So these are the electric vehicles are there, charge stations are there, substations are there, how they are using, and finally these are the residential, industrial and commercial. We have mobile phone, we have tablet, we have industry, and we are going to utilize. So this is the complete chain, layer 1, layer 2, layer 3. How the, so here information is going to transfer from this layer to this layer. So data will be the one part. So how much energy will be generated, that will be available, and we have to provide various forecasting. We have to provide the secure mechanism, that means whatever the security concern will be there, and safeguard communication will be there across the network. And network management is very important part here, because we are going to maintain the communication to the next layer, next stage, that to maintain the quality. And finally standards call a chain area network, that will be superimposed on power chain. So these are the certain aspects are there. Traditional power grid where we were using earlier days, and we are going to replace by smart grid. So smart grid, centralized and distributed power plants are there. Only centralized sources of power. Energy flow was unidirectional, bidirectional, and it's a component point. So component, that means customer participation, that means passive participations of customer, but here active participations are there. Real-time monitoring, it's very limited, but here real-time monitoring will be there from generation to the customer. And integrations with renewable. So here difficult to integrate renewable sources, but here easy to integrate. And finally energy supply failures. So no energy during failure or blackout, but rerouting will be there. So some area if the failure will be there, by the intelligent mechanism they will find other area. So other route will be find out. Other substation would be identified and will be given to the energy. So that means there is a standby mechanism will involve here. So rerouting and islanding mode ensure the supply reliability, and reliability is one of the factor in this domain. Peak saving, so not possible due to the unidirectional flow. Here possible because electricity can be sent back during high demand. So all these are the comparison when we'll compare with traditional power grid and as compared to smart grid. So upgrading present grid in terms of, and we are going to integrate the renewable energy resources. So it's a grid transitions in that level. So how, so when we will see that after 10 years you will observe autonomous driving car or driverless car, smart watches or various smart systems that will arrive. So how will utilize the power resources? During that time more power is required because data is increasing day by day, and power handling capability also we need to go for more. So upgrading of present grid to smart grid is one of the requirement. That integration is necessary, but current grids require upgradation across multiple operational aspects, including generation, including transmission, distribution and system planning. So there is this enhancement is our aim. So our aim is what? To improve the grid flexibility. That means we have to improve the grid flexibility to accommodate the transformations and whatever the diversification is required. That means based on that we have to integrate the renewable energy resources, RE. So this is the smart, this is the earlier grids, now we have transmitted in terms of, transform in terms of smart grids with respect to various technology. So renewable energy grids, there are certain challenges and solutions are there. So we may get it idea about how variability will be there, unpredictability of that. So challenges is very difficult to manage the power flow. So what is the power flow of energy generation will be there, and what is the solution? So we are going to provide AI power, artificial intelligence, that need to be integrated. And what AI powered? So AI powered forecasting. That means we are going to predict through the artificial intelligence. That I said yesterday, machine learning is basically required for prediction, or we have to take the decision based on the current data. In future, if new data will come, we will be able to make preparations. That means what kind of changes we can do in grids, what are the condition the failure will take place. So all this analysis we can do. So according to that, AI powered forecasting models and battery and storage systems, that is more important. That is a solution when we want to go for variability and or unpredictability of renewable energy. So we can predict the renewable output. What is the output of the wind will be there, what is the output of hydropower will be there, what is the output of, like just morning sir explained about hydrogen and other aspects. So related to that we can balance supply and demand, how much supply is required. So as of now, just assume that in 2025 how much power requirement is there from the user point of view in Hyderabad or in Warangal or any city like Mumbai, Nagpur, Pune or Bangalore. So 2026 same requirement will be there? Same not, because you can see the appliances are increasing day by day. People are buying many appliances or power requirement is increasing. So same rate, whatever the energy you are using at your home, every month same rate you are using. Can you predict that one? So sometime you are using 150, sometimes 160 units, sometimes you are using 170, and in summer it will be more. It may be utilized 280 to 90. And because of we are under the seasonal condition, winter time, North India winter is very cold, but in South India winter is not that much cold. So energy consumption in both sides is very different. So we have to predict as per that, and grid system need to be managed. So smart energy system, that mechanism we need to apply. That means how AI can identify whatever the energy power consumptions that is identified from the past 1 month, based on that prediction will take place. So that is required, because we can compute the demand. So suppose last month 1 kVA was required, that means next month 1.1 kVA will be required, next to next month 1.2 kVA will be required. That prediction will take place based on the AI algorithms. So based on the data which we have collected from various energy meters are there. Now energy meters also became smart energy meters. You can observe now, previously 10 years ago there was no smart meter was there. So after some time it may connected to internet, it may give the data to directly to the as computer, and computer will be able to generate the reports, and many things will be able to take place. Data will be continuously collected. So ultimately without power, no use of any mobile, no use of any computer, no use of any device. So one day if you will not charge your phone, will you able to use? So you have to carefully work related to power generations, power transmissions and power delivery. And deliveries is variable, it's not a constant. Delivery is not a constant. You cannot work. That's the reason AI driven algorithms, they are identifying. So grid modernization is one of the requirements. So aging, earlier days you are buying the product, you are worrying about reliability, but reliability was one of the factor. In electrical engineering, we started from electrical, but we entered into the electronics. But electronics is not complete the core branch. Electrical is the main core. We are working under electrical. We are the circuit people, but we are working electronics plus electrical must be there, because without electrical you cannot realize electronics. Understand? So electrical engineering like KVL. So KVL and KCL you are using in electronics or not? Without that you cannot realize the circuits. So definitely we need to understand what way we are going to modernize the grid system. So grid modernization is one of the requirement. That means we are going to make them like sensors became smart sensors. Grid became smart grid. Smart means intelligent. That is self-healing. Self-healing means if suppose failure will take place, system itself will just rectify the error. Previously it was not like that. System error we are unable to manage. The particular technician has to go and check where the error. But in the particular computer itself we can realize where the error will be there. And self-healing will try completely to diagnose the error and remove the error also. That is the main motto of AI. So AI driven algorithms which are ready to utilize. So modernization will be possible, and one of the factor is reliability. Reliability means aging. So every product will be working like a bathtub. That is a starting, and then constant failure, and the finally wear out failure. Wear out failure means after 20 years your product will be wear out failure. You cannot repair them. So constant failure, that means it will not degrade, it will not damage. 10 years the product will work, but in between if some error will come, you will go to the technician, you can rectify. But after 20 years, suppose your motherboard of that mobile phone has gone. So what you will do, you will replace the phone, you will not repair. That is out of repair. Failure rate, it gone to failure rate. So reliability factor was one of the important. Nowadays reliability is for every product not necessary. Like mobile phone, not necessary. Reliability of mobile phone 3 year, 2 year only. But some product like television, laptop, or some other product which we require reliability, it may work 10 years, it may work 15 years also. So based on the company, they are providing the particular reliability. So here aging infrastructure and high energy losses during transmission. So it's promote distributed energy system. That means by using of rooftop solar to reduce the grid dependency and transmission losses, and collaborate with policy makers for new infrastructure regulations. Similarly, frequent power outage. Challenges, outage is because of weather. As I said, extreme weather, different weathers are there, aging infrastructures are there. So we have to provide backup sources. Distributed systems, like a battery. You are using some places the electricity cut is more. So what people are using? Inverter people are using. They are using backup. So, but nowadays very less people are using the inverters, because in Barangal there is a only Saturday sometime power gone is there, 1 or 2 hours. So we need not require to use inverter. So if the one day 4 or 5 hour cut will be there, then go. So battery storage can ensure that uninterrupted power supply during outage. Electromobility, that like electrical vehicle. We are using electrical vehicle, now we started more. So adoption create a new demand and potential grid instability. So smart grid with real-time data analytics, with battery storage, we can manage the electric vehicle charging, bidirectional flows, and voltage fluctuation. What will be the voltage fluctuation will be there. So to provide the electromobility, device will require to utilize for one place to another place. Suppose your car, whatever the electric vehicle you are using, two-wheeler you are using, and it has discharged after 50 kilometer. So you have to manage your charging there itself also. So you have to use some power source and charge it. So that is the mobility. So smart grid with real-time data analytics, battery storage will manage the electric vehicle charging. Finally, security threats. That means we have to understand about the security concern, because we have increased the vulnerability to cyber and physical attacks. So various cyber and physical attacks, that is threats have started. So use microgrids, distributed generations, and blockchain technology. So we started to use blockchain technology to decentralize the systems and reduce the single point vulnerabilities. So this way we can use the various challenges and their solutions are there. How grid modernizations and preparing for renewable future. So that is possible based on the digitizations. So we have the digitalizations, advanced sensors, advanced analytics. We can improve the grid visibility, and this may be enabled in terms of real-time management for renewable sources. Second is upgrading infrastructure. We have to improve the transmission lines being upgraded to handle the increment of the flows and reduce the bottlenecks and congestions. Third, smart inverter. So inverter also became smart. That means automated systems, completely automated switching will take place. So smart inverter grid support functions, and this function include voltage and frequency regulation. So we have to manage the voltage, we have to regulate the frequency with the smart level. So these are the grid modernization techniques we are preparing for renewable future. So decentralizing trends with respect to local energy solution. So we have the three different tasks. What we are doing, microgrids. What exactly will do? Improve the energy resilience in communities, and also it enable the local generation. That means local area we can generate the power and distribute it. Second, rooftop solars. Nowadays many apartments people are keeping the rooftop solars. They are utilizing the solar energy and giving the power to the entire apartments and saving the, and government also giving the subsidy to entire for that on projects. So residential solar panels, residential area people can use solar panels or empower the home owners. They can utilize the, like in place of geyser, they can use completely solar based geysers. So completely, but it is the only weather condition, it will not work. That is the some pros and cons are there. So they reduce the reliance on centralize the power grid. You should not depend on the power grids. If power failure will take place, we can get the like standby power, like lifts are working in the apartments, or particular this centralized complete geysers are working with respect to power, or many other factors. A 1 or 2 bulbs in each house can be utilized solar power. So standby backup will be available. That is the more important. Community projects. So community, they can on the particularly renewable energy projects for foster engagement, and it is very essential for sustainable energy transitions. So many communities they are using all these kind of aspects related to decentralized trend, local energy solutions. So according to renewable energy sources, it depend on power demand and whatever the policies are there in South India. So various reviews we have seen, various articles we have observed. In that article we found how the renewable energy, how we can mix with power productions, what are the way power productions are working, what are the demand policies are there, what are the investments governments are doing, especially for South India. So they have proposed certain thermoelectric generator model. In that model they are using solar dish collector technology, solar collector technology to meet the rural demand, because rural area there is a main problem, because the farmers are facing problem. They are getting electricity in night only, and they have to utilize, they have to give the water to the plants. How they will manage? So standby mechanism will be given. They can install this kind of system in with respect to based on the policies. So the model employ the parabolic concentrator. Parabolic concentrator of the solar panel will be there. Thermoelectric model will be there to generate the electricity directly from solar energy. So this is the one of the case study we can observe here. So what is the trends are there renewable energy in India? So we are leading producer and we are very ambitious. We have the ambitious goals. Now we are generating the power, and the third, solar power leader. So India is world third largest power consumer. We are required that much, we are in third with respect to power consumer, with than renewable energy producers also, related to renewable sources and accounting 30% of total installed capacity in 2020. And as India's aim is what? To source half of its power from known fossil fuel sources. That means we want to get the power from known fossil sources by 2030. That is the aim given by the Indian government. And produce the 175 gigawatt of renewable energy by 2022 and 500 gigawatt by 2030. And we want to become a solar power leader in all over the world. So it will be possible because India is home to 3 of world largest solar parks are there, and including the 2255 megawatt, that is the Badla solar park in Rajasthan developed. So we can see how renewable energy resources we have started in our country. So related to energy mix in southern states, we can get it Andhra Pradesh, we may get it Tamil Nadu, and we may get it details about Kerala. If you will see, the Andhra Pradesh has the total installed capacity is 20,081 megawatt with focus of solar power, an aim of meet to power demand while minimizing the carbon emissions. And in Tamil Nadu, they have diverse power generation portfolio up to 31,894 megawatt capacity, including 15,779 megawatt from sustainable sources only, like wind and solar energy. Similar way, in Kerala, the power generation cover 52% consumptions with the focus on hydropower. They have focused hydropower and increment demand on solar capacity 2,500 megawatt by 2030. So this is the status of energy mixing in southern states. This is the policies in South India related to Andhra Pradesh, focus on solar power projects. They provided many policies related to solar power project. They have given rooftop systems, they have given solar parks and solar powered pump sets. The government has provided many projects and we initiated many communities. As in Karnataka, encourage renewable energy projects with respect to wind, solar hybrid project they encourage, distributed generation also they encourage, and Kerala they promoted solar panel installation and solar water heating systems. And Tamil Nadu, if you will see the encouragement consumer to become prosumers and configure the new energy meters. So they configure various new energy meter in Tamil Nadu to manage the all energy resources. So we can visualize the energy resources in this. So how budget allocation and future direction will be there? That means increasing the investment. As of now, we can observe the cost is power generation would be high. Okay, so we have to bear that cost because initial cost will be bear to users only. So how to decrease the cost with power generation increase and how to manage investment. So increasing investment, budget allocation for clean energy and increasing the across South Indian states, indicating that commitment to sustainable development. The second, thermoelectrical generation. How we are going to get this? So thermoelectric power generation is suggested as a alternative energy resources. This is the production method to utilize to implement extensively. And the third, sustainable development goal. That means SD became very popular from the past 5 years because of that means we want to give the efforts aligned with United Nations. They given the United Nations has given the main idea that sustainable development goals. They provided certain goals. So that goals are needed because we have to promote the clean and clear energy and affordable energy. That is the mandatory requirement. Based on the UNO goals, every countries are working for sustainable development. So Denmark's renewable energy transition. If you will see in abroad, Denmark has successfully transited from coal to diversify mixing of renewable energy resources, and they were driven by the supportive government policy. That means they have done all this with the help of government policies only. And related to Denmark energy mix conditions, they utilize wind energy. That means Denmark leads in wind energy. They are leading. They are producing 40.7 of electricity from wind only in Denmark. And there are many projects are working there, and they are promoting solar contribution 2.8. growing segment with potential future expansion. Related to biomass, because waste or waste material or biodegradable material, how they are going to utilize. 17.8 divert from biomass and waste, promoting sustainable resources use. And the last, market approach. Their market approach is very flexible energy generation, and they are importing to the power to the other nearby country in European states. So Denmark's wind power historical perspective will be there, because early beginnings, Denmark's journey begins in the late 19th century. There is a small wind turbines powered rural communities. They started from rural communities. By 1970s, that oil crisis was there. So government support for wind power increment, as well as modern, this in current technology, because we develop IoT, we develop like AI and machine learning. So advanced technology and grid integrations, the strategies they utilize for crucial for large scale adoptions. So this is the wind power historical perspective in Denmark. So whatever the wind capacity growth and milestones was there, 1980s initial growth in wind capacity driven by the government initiative. That means started from government initiatives and technology and advancement. By 1990s, significant expansion that was done by larger wind farms and improved turbine efficiency. By 2000 onwards, continuous growth, integration wind power into national grid. As current condition, Denmark is a global leader in a wind energy with the high percentage of electricity from the wind. So they have developed their infrastructure to generate the power with respect to wind energy. So that is the policy they utilize, how they started and how they reach now. And whatever the supportive policy frameworks, that is the feed-in tariffs. So guaranteed prices for wind energy producers they are giving, and encouraging the investment. They are giving the some promotions, subsidies also. Renewable energy targets are also they are having. So ambitious their target for energy renewable consumptions and driving wind power development. The third, tax, that means incentives. They are providing tax deductions in terms of reduce the taxes for wind energy projects. So who are doing the project under the wind energy, they are reducing the tax and promoting and making them more financially attractive. Last, that means streamlined permitting. That means efficient processes they are providing for obtaining the permits for wind farm construction. So there are many wind farm constructions are there. So they are developing them with respect to the efficient processes only. And with respect to flexibility they have given with respect to grid. So they employed the grid flexibility strategies, I think related to smart grids. Smart grid completely advanced technology, how to manage the electricity and energy storage. So various batteries, various backups, various other solution they have provided to store the excessive wind power and demand response. Whatever the demand of the society or community will be there. So adjusting electricity consumptions based on the wind power availability and interconnection. So they connected with neighboring grids, whatever the neighbor grids are there, to balance the supply and whatever the demand of the supply based on the demand they are providing the supply. So interconnection of various other grids, they are managing balancing. So this is the visualization of impact of key data and their charts. You can see Denmark success, notice rise in wind contributions from 2010 to 2012, then 14, then 16, 18. Now see that. So last 10 years, whatever the contribution will be there, that we can visualize with this data. This is the lesson learned, and with whatever the future applications. So with respect to policy support, stable policies are very, very important. Technological innovations also very important, because continuous improvement must be there. That is the key requirement. And collaborations with respect to various partnerships that will drive the success. And grid must be modernized. So grid modernizations with current technology need to be modified with the advanced technology. That is the main important part. With respect to flexibility is very crucial. So Denmark as a pioneer in a wind energy, with respect to this is the one of the best energy resources. So Denmark became global leader. It's a ambitious goal. So it's established itself a global leader in wind energy. Country has consistently pushed the boundaries of renewable energy adoptions. and they adopted, that means set a ambitious target for transition fully renewable energy system, and aim of this system is to their carbon footprint significantly they want to reduce, and sustainable future. So Denmark is looking, and commitment is sustainability is very important part that is evident for long term energy planning. So they focus on creating on green and resist whatever the resilient economy will be there. So this is the their main, they are in the particular pioneer in wind energy. So whatever the strategies they apply for renewable energy integrations, so grid connections, first thing is grid connections, so reliable transmission and initial energy sharing. After that, energy markets, so they trade energy market related to electricity across the borders, and power plants, so they want to adjust generation for renewable supply, forecasting tools, so they want to predict whatever the energy resources they are generating, what is the demand, supply will be there, and what is the demand will be there, and how we can predict that energy, renewable energy productions based on the requirement. That I said machine learning and deep learning models are important to forecast. So related to clear rules, they encourage the renewable energy growth, and finally Denmark aim 100% renewable electricity through advanced grid and interconnection cooperation. They want to completely remove the petrol and fossil fuels from the market. They want to go for 100% depending on this renewable energy resources. So they want to just convert the complete grid into modernize. That is the main expansion for renewable transmission. So infrastructure must be upgraded, capacity must increase, and regional integration must be there. That means whatever the new transmission lines they are using, that will connect to renewable energy resources only. Second requirement, boosting the grid capacity to handle the fluctuations and renewable energy flows, as well as connecting the grid across the region. That means various regions the power supply more but demand is less, so they have to balance. That means to manage the balance with respect to supply and demand. So whatever the smart grid revolutions there, digitization to now grid management. So smart meters, as of now we have seen in India also we are having smart meters. In smart, they enable real-time monitoring of energy consumption, so we can manage. So if suppose if someone is not using some bulb or something, so automated stop will be there. So how to stop, that kind of thing is smart management, smart automation system. So by that way advanced sensors are needed. That means they provide the detailed grid status information for improved control. And last is more important, data analytics, data science. There AI will involve. That means optimize the grid operations and predict the energy demand, forecast the energy demand, predictions of energy demand. That will be required for smart grid revolution. So we are going to powering the futures. So energy storage innovation, that is there in innovation in Germany. So Germany battery storage, large scale batteries they are using to store the excessive renewable energy, and that is the pumped hydro. So utilizing the water reserves for energy storage they are using, and hydrogen production. I said of morning sessions are said converting excess electricity into hydrogen for later use. In future also we can use that energy in terms of, so hydrogen production is very important. So Germany and Denmark, they are pioneer in terms of renewable energy. Germany, Denmark are the forefront related to global transition to renewable energy. Their experience in implementing this large scale renewable energy system, they have provided valuable insight in other countries also, seeking to reduce their carbon footprint, enhance the energy security. So this presentation explore the strategies, what kind of strategies they utilize, successes and challenges faced by these two countries, and they strive towards the sustainable energy futures. That means they strive towards this sustainable energy. So what is the energy band? That means what is the policy and ambition will be there. So energy particular definition point of view, energy band, Germany energy transition is a comprehensive policy framework that aim to shifting from fossil fuel to the nuclear power for renewable energy resource. And the policy makers, the primary goal include reducing the greenhouse gas emissions, increasing the energy efficiency, and expanding the share of the renewable energy resources. And ambitious targets. So Germany, their aim is to achieve the significant reduction in greenhouse gas emission by 2050. They want to reduce, with the renewable playing a central role in the meeting this target. With respect to renewable energy, only they are able to reach this target only. So that is their ambitious target is there by making the policy goals only. So German people have utilized solar and wind integration strategy. That means Denmark utilized wind. So they have started feed-in tariffs. So guaranteed payment for renewable energy feed into the grid incentive investment. Those who are working related to solar and wind power projects, ensuring stable revenue streams they will give. That is their policy. Second, priority grid access. That means renewable energy sources have given more priority. Those who are using, they will give more priority to them to access the grid and to facilitate their integrations, to minimize their or curtailment during periods of high productions. And finally, third, Renewable Energy Sources Act also they made. So the EEG provide legal framework, because the government has to provide certain framework to promoting these sources and set the some target, those who will expand this kind of thing or driving innovations, investment in this particular sector, so they will help. So these are the three strategies are there to integrate the solar and wind. So modernization of grid in Germany, and it became Germany smart grid approach. So they utilize smart meters, they utilize grid expansion, and they utilize energy storage services. So deployment of smart meter, it will make real time monitoring of energy consumptions and what is the productions, whatever the requirement, whatever supply will be there, facilitating demand, response, and grid optimization. If it is more supply will be required, they are optimizing the grid. Same thing, grid expansion. So investment will be given to grid infrastructure. That is main important part for accommodate increment share of renewable energy, and they ensure that particular reliable transmission from remote generation sites, remote areas. Also energy storage, because of development of energy storage like a batteries, particularly for electric vehicles, batteries are needed. So such batteries, pumped hydro, they will help to balance the supply and demand and address the intermittency of renewable source. So these are the three different modernization factors of the grid will be there in Germany they utilize. So energy went result, success and challenges. So whatever the success and what are the challenges are there. So according to factor in renewable share, Germany has achieved significant progress increasing the share of renewable energy, electricity mix exceeding 50% recent year. And grid stability, they want stable grid. So despite of high penetration of renewable sources, Germany grids has maintained the high level of stability, demonstrating the effectiveness of grid modernization effect. They manage and emission reduction. So Germany has made stride reducing the greenhouse reductions, gas emissions, although further efforts are needed to meet this long-term climate targets. They made some long-term climate targets to maintain the emission reductions, to maintain the grid stability and renewable shares. So these are the key takeaways, lessons from Germany and Denmark. So for that we should work as a policy makers, we should make the system modernized, and how the regional collaboration will take place. These are the three different needs are there, these are the three different targets. So with respect to policy makers, supportive policy must be there. They must support to the people who can utilize, including feed-in tariffs or renewable energy targets. It is very crucial for driving investment in renewable energy. Second, grid modernization. So we have to invest, we have to provide the investment in smart grid. So related to smart grid, the grid expansions and energy storage, and particularly it is essential for integrate this technology with high shares of renewable energy. And third aspects, regional collaboration. So we can see that cross-border energy collaboration. So cross-border energy collaboration is also very important. That will enhance the energy security, reduce the cost, and facilitate the integration of variable renewable energy resources. So these are the key takeaway lessons are there from Germany and Denmark. So regional collaborations like a Denmark energy exchange from North Pole. So Denmark participate North Pole. It's a power exchange platform that facilitates the cross-border electricity trading among the Nordic and Baltic countries, as well as enhance the security. So regional collaborations enhance the energy security, in particularly diverging the energy sources, providing the access of larger pool during the period of high demand. And the second, interconnected capacity. That means Denmark particularly has invested in the high capacity interconnections with respect to like Norway, Sweden, Germany, and they enable the large scale electricity trade and they manage the grid balance. That is the main important part. That means first they manage North Pole, second enhance the security, and third interconnected capacity. This is the regional collaborations are there related to Denmark energy exchange. Now the case study point of view, integration of micro and smart grids into that. And one more country is there, Bangladesh national energy system. This is the one of the case study related to sustainable energy system. So according to that integration of micro and smart grids, if you see in the Bangladesh, the need is reliable and diverse energy mixing will be there. That means reduce the emissions, reduce the energy independence, and also decentralize the energy solutions, and particularly grid stability, and grid must be flexible. This is the main need for reliable and diverse energy mixing will be there. Related to this case study, if you will observe, that means what are the microgrids and smart grids are there. What is microgrids? That is localized energy networks are there. That is called microgrids, and they are having enable energy autonomy, particularly local renewable harvesting. But in smart grid, utilize real-time data. Real-time data will come, and also it is completely automated. And the last case, enhance the grid stability. These are the difference will be there with respect to microgrid and smart grid. So what is the potential of microgrid will be there in Bangladesh? We want to reduce the load. Whatever the load sharing concept will be there, so we have to reduce the load as well as reduce the particular load on centralized grid, and energy resilience. So whatever the energy resilience will be there related to energy and reliability, and renewable energy motivation. So facilitate the integration of renewable energy, and finally rural electrifications are there. So it will support to rural electrification. These are the potential which we have seen in microgrid integration in Bangladesh. So what are the synergetic benefits with respect to microgrid and smart grid integration will be there? That means energy efficiency will improve, reduce the footprint, especially for carbon footprint and carbon emissions. Third, grid reliance, and fourth, renewable boosting. So all these factors improve the grid reliability, and particularly for autonomy, system will be automated, and community engagement. These are the factors are there. That is the synergetic benefits to utilize for micro and smart grid integrations. What are the key takeaways from that countryside? So they have increased the resilience, they have decreased the footprint, and they have utilized the more renewable energy. They adapted for renewable sources. So in implementation from smart grid bolster system, they have reduced the carbon footprint. So in South Africa energy transition, that is the fourth point of view case study. South Africa is grappling with significant energy challenges are there, including widespread lack of grid electricity or reliance on coal. That was the main factor. So government aimed to develop the renewable energy resources and reduce the carbon emissions and meet the future energy demand. So they particular in these examinations will change the potential challenges of integration of renewable energy, especially for South Africa energy mix will be there. So there are dual challenges, but because demand and crisis. So energy demands in South Africa, they are facing the problem of sustainable energy defects, like leaving many without access for grid electricity. So this is the many particular reason of shortage of this property affects a rural area and hindering economic development and social progress. The second factor, over reliance on coals, because this country power supply is critically dependent on coal only, coal fired power plants. Almost they are making sustainable to supply the disruptions and environmental pollution. That is the main limitations because of investment in energy sector research. That is the exhibits this issue. And the government response. What is the government response factor? So government strategies involves expanding the renewable energy resources like solar, like wind, while simultaneously they want to explore options like a gas they can imports or nuclear power. So particularly this will diversify many approaches related to the aim is to ensure that reliable and sustainable energy supply, particularly for a future prospect. So this is the dual challenge, demand and crisis. So renewable energy potential and integration, what they adapted related to that abundant resources. That means South Africa is blessed with rich solar and wind resources. They are rich with that. So they are presenting a valuable alternative for power generations. So renewable energy resources, what they utilize, that means they have helped to reduce the country's carbon footprint and ensure the long-term energy security. Another, they made policy framework. So in 2009, National Energy Regulator NERSA, they introduced the particular law, that is tariff REFIT policy, and this policy aim is to encourage the adoption of renewable energy for establishing the price, particular whatever the good price will be required, frameworks are required for various sources, and thereby they can reduce the burden on coal. Particular they were using the coal fired plants, and market they made dynamics. That means whatever the policies they made, they promoted the fixed purchase of prices and they buyer and seller framework to for their mirror particular market will dynamics. Then particularly they are having the simulate the renewable energy project. So approach was incentivize investment and facilitate the integration of renewable sources into whatever the national grids they are using. So they want to integrate the solar, they want to integrate with wind. So they made the certain policy, and they based on that they provided certain subsidy and certain reduction in price. So there are certain challenges and path forward will be there. So resources variable, that is the variability. So integration of renewable energies resources into current grid system, that is the main system we want to study here. So integration of renewable energy factors, that is hurdle because of resource variability caused by the atmospheric condition. Like in India we have the weather, different weather, different places. So overcoming this requirement, the innovative storage solution they provided and grid management strategies they changed. Similar way, limited rural transfer, their rural transfer is very limited. So another challenge, that is also limitation ability for transfer the energy, as especially for rural area like in India for village people. So where the renewable sources are located and urban areas, investing the transmission infrastructure is very crucial in effective integration. And third, that is the third challenge, urban photovoltaics. So in urban area, whatever the photovoltaic system we are using, it's a sustainable option for both private and municipal cases. But they encourage the adoption of photovoltaic system and can reduce the reliance on national, and particularly they promote the energy infrastructure. So this is the main challenges and path forward will be there. So another country, that is the case study on renewable energy development in Azerbaijan. So Azerbaijan is focused particularly diversifying the energy sources. Aim is to reduce the reliance on fossil fuels. So they started to work on that direction. Country has promoted sustainable energy stations and solutions. They utilize the renewable energy sectors and it is growing. So renewable energy capacity is 2022. Hydropower 1000, so 1,159.2 megawatt across 30 stations and includes major plants like Shamkir and Minigature. So wind energy 66.1 across 8 stations include hybrid plants like Gobi station and Julfa, and solar energy 51.9 across 12 stations, that is located in one place. Bioenergy 37 megawatt from 2 stations, total include 1 hybrid plant. So this is the capacity of 2020 in that country. So electricity generation 2022, you can see this is the hydropower, this is the wind, solar and biomass. This is the hydropower. Completely maximum is hydropower. So renewable energy contributed 7% of total electricity production. Total electricity production reached 28 billion kilowatt. So this is the particular another country, that is the Maryland, USA, solar power photovoltaic integration. So objective is they studied and they conducted under the US Development of Energy, and they address high solar penetration. So related to that, whatever the key issues, reverse power flow caused by high solar photovoltaic injections. So potential impact, high voltage level in distribution network, increased short circuit scenario, faulty protections coordinations, and improper functioning of control devices. So proposed solution, regulate the reactive power will be produced by solar photovoltaic to mitigate the reverse power flow. Challenges, very difficult to regulate reactive power because of limitation of energy production from solar power, and development of alternative methods needed to address reverse power flow. These are the challenges are there. So according to that, the case study in this is the real world resilience case study in grid management. So in California, in Texas, in a Europe in country. So California grids has successfully integrated large amount of solar energy. They utilize advanced forecasting energy and this cross border cooperation support that is the continent's renewable energy goals. So basically when we will see the real world case studies, they demonstrated effectiveness of innovative grid management practices from California solar integration to Texas wind energy expansion and Europe cross border energy trading. These are the examples to highlight the potential to achieve the reliable and sustainable energy future. Through this we can get the strategic grid management system and technological advancement. So as per this real world resilience, how we can see the grid management utilized, and they have utilized integration of renewable energy into India's power grids. So now we will see that explore Indians integration. Now integration of Indian renewable energy resources in India power grid, drawing lessons for international case studies and focusing on Indian context. We will examine that challenges, strategy and future as prospect incorporating renewable energy to meet the climate change goals and while ensuring a stable and reliable power supply. So these are the global and Indian context are there. Global shift, renewable sources like solar and wind are crucial for meeting the climate change, reducing the global warming and providing the carbon free energy. So prices have dropped from rupees 2.5 to 3.0 kilowatt per hour, making them competitive coal based thermal energy. And India's ambitions. So the India aim is 175 gigawatt for renewable energy by 2022, and including 100 watt solar and 60 gigawatt wind. And hydroelectricity once a major contributor in India, because for around 20% electricity generation will take place by hydropower, and goal is now 450 gigawatt of solar and wind by 2029 to 30. That is the our country goal. And strategies what we have utilized for renewable energy integrations, same forecasting, same flexible sources, same energy storage. In these aspects, accurate forecasting of solar and wind energy is very essential because of the intermittent nature And renewable energy management centers use advanced technology including AI and precise prediction, as well as hydro and natural gas provide the flexible power source, but their scale is declining. So coal based power stations are being upgraded for flexible load operations through the long term reliability still under evaluation. Third, energy storage. So we want to get efficient energy storage is the very large scale renewable integrations. Pumped hydro storage dominates, but battery and other systems are rapidly developing. So green energy particular corridors which are we have utilized for construction of transmit renewable power. So these are the certain strategies are there for renewable integration case study, the lessons from India, like Denmark, like whatever the Hawaii, or like South Australia. So Denmark market based approach including storage, transmission grid, international electricity markets, flexible generation system, and their aim is 100% renewable electricity by 2030. For Hawaii, that is the particular shifted from 92% oil to now significant solar power with battery storage, flexible in thermal oil based production, and increase the energy storage were key. And the South Australia, they manage the high wind generation with synchronous machines with output curtailment and interconnection. So distributed energy resources, they meet the sustainable portions of demand. These are the certain international case study lessons for Indian countries are there. India and Gujarat, there are energy renewable energy actions. The national scenario point of view, the detailed modeling suggests renewable energy curtailment may be necessary for some days. Gas based capacity that can be increased full solar and wind generation. Gujarat's approach, so Gujarat aims for 44 gigawatt for solar and wind energy by 2030. The strategy they include demand side response and flexible operations for the coal plants and battery storage for enhance the renewable energy absorptions. Demand side response, so agriculture account 20% consumptions are needed, mainly for during night hours. As I said already, Indian governments are providing electricity to night hours to them because they are giving water to the plants. So agriculture provided energy during the daytime using the solar can be reduced 3%. So that is the main case will be there. So this is the renewable energy actions in India scenario. So conclusion point, the path forwards. These are the key steps. So integrated grid system with accurate forecasting system, flexible coal plant operations, and battery storage and demand management. These are the key crucial renewable energy integrations are needed. And for future outlook, energy from renewable electricity generation capacity must reach 50% of total capacity by 2029-30, and we should provide the 20-25% total electricity generations, as well as looking at providing more gas generation will allow integration of 50% renewable energy generation. So coal will remain an important source for power and energy. So this is the concluding part. Into machine learning, so we have to work data driven insight. So machine learning algorithm extract the valuable insight from large data set, enabling more accurate predictions and informed decision making in energy sectors, and this is useful for load balancing and predictions. Similar pattern recognition, so machine learning will identify the complex pattern of renewable energy, so generations and whatever the consumptions of data will be there, leading to improve the forecasting and optimization of energy system, and it will include the pattern recognition. Adaptive learning, so machine learning can adapt and improve the time they expose the new data also. As I said, we can find out the information with new data, making them well suited for managing the dynamic nature of renewable energy, and then we can integrate and varying load also. So real world load is never static, that is the main factor here. So we can get the adaptive learning, so dynamic nature of the renewable energy integration and varying load, we can make a model they can adapt and improve over that time as they expose new and new data. So this is the real world success story, how machine learning in modern power grids. So Google's DeepMind, they are using the machine learning to optimize the cooling system in various data centers, and resulting 14% reduction in energy consumptions are there. And this idea save the millions of dollars and reduce their carbon footprint. Second, smart wires implemented by machine learning, that solution to optimize the power flow through transmission line. What is the power flow will be there? So increasing the grid capacity and reducing the congestion, and this allows the more efficient use of existing infrastructure. Third, STEM they are using a machine learning to optimize the energy storage systems, and they enable the business to reduce the peak demand charges and integrate the renewable energy more efficiently. Storage is the key to peak the load leveling. So I'll stop here. We can now take a break. We'll meet after 10 minutes. Based on that, you can make it, and it will be work as a ground truth. So you have the exact ground truth and you have the predicted output. You have to map that one. So if you have received 90%, that is you have matched. Suppose 80% you have matched, 70% you have matched. So the possibility will vary. This will be identified by related algorithms. So whatever the algorithms we are using, based on that related outcome will come. So sometime that one algorithm will provide best result, sometime it may fail. So depends on the what kind of data we are using, nature of the data. Then based on the problem statement we are using. So here problem statement that would vary. That role of AI in power system. If you are talking about, so AI is revolutionized power system with real-time insights and automation to improve the particular power efficiency. So operational efficiency, we can reduce the energy loss, we can optimize the resource allocation, and another factor, sustainability. So we have to support renewable energy integration and carbon emission reduction. So our concern is to understand that sustainable development means to we have to understand how much time we are using carbon reductions and how we can use the sustainable energy. So application of AI in power system forecasting. We have to predict power demand, energy productions, optimize. We have to understand the various algorithm. That algorithm will responsible to for understanding of load balancing and smart grid efficiency. Third, fault detection. So we can identify the potential failure anomalies, that is early to predict the breakdown. Control and automation. So we have to enable the dynamic voltage regulations, demand side management, and renewable energy integration. So we have to integrate renewable energy through AI. So AI will help smooth integrations, variability of renewable energy sources. Finally, AI promote the development of self-healing grid. As I said, self-diagnosis, self-healing, self-improvement. That will be repair, self-repair for particularly faster outage recovery. So power demand forecasting we can do by AI. That means we can do how power forecasting will be there with respect to artificial intelligence. So AI will predict the electricity consumption pattern. What is the pattern of Warangal? What is the pattern of Hyderabad? Then in the different area of the Hyderabad, we need to predict the pattern of electricity, and based on that, we have to take the historical and real-time data. Why forecasting important? So forecasting because ensure that grid must be stable. Grid must provide the electricity in the properly, otherwise grid failure will take place. So we have to understand the stability by preventing overproductions or underproductions. Reduce the operational cost by optimizing the energy production schedules, and help to grid operators plan for peak load periods and seasonal. That is the power demand forecasting. AI technology for demand forecasting. That means we are using regression models. So various regression models are available that use for linear or no linear regression model between past and future energy demand. As well as example, multiple linear regression techniques are there that we can use energy consumptions based on temperature, season and historical data. That means you may get it 1 year of data from Warangal city, Warangal urban, Warangal rural. With respect to data will be there for 5 grids are there and how many users are there. So one side you have data in terms of temperature will be there. So January temperature will be different, June temperature will be different, November temperature will be different, and with respect to season also vary, with respect to demand also vary. So March, May, June and July the people will use more AC, air conditioner people are using more, but October, November, December less. So consumption will be less. So demand also will be less during that time. So that is the factor we are going to determine. Same long short term memory network, LSTM network. LSTM also will be divided to GRU and other types. So type of RNN specialized that is working for time series data. So whatever time series data, so practical lab will be there to analyze the time series data forecasting. So here capture the complex pattern and long term dependencies. We can predict the hourly people are using particular power or daily what they are using, and whatever the seasonal demand will be there. Same time auto regressive model we are using, that is a popular statistical model, short term forecasting. That means short term forecasting that we can do with the help of this algorithm, and effectively for capturing the trends, seasonality in historical demand data. That means whatever the demands are required, based on that we can predict it. Similarly, real world examples, that means utility companies was using AI model for accurately predict the weekdays, weekends, what is the demand patterns are there, we can prepare for extreme weather event. Likewise, benefit of AI in terms of forecasting. So we can minimize the energy wastage, we can prevent the overloading on the grid, as facilitate the better planning for energy, renewable energy integrations, and when peak load requirement will be there, and help to reduce the particularly overall electricity prices. The prices of electricity we can reduce by applying of optimizing energy procurement. So related to same way we can use predictive maintenance, that is the another technology through AI in power grids. So you can see here AI will identify the early signs of equipment failure. That means once equipment is going to failure will take place, we can early determine, we can early detect them. So by using of analyzing the sensor data, various sensors equipped with the grid, we can identify this at that this time the grid failure will take place, and what is the possibility will be there. So technology is anomaly detections or identify the irregularities in equipment and behavior. Then we can improve the reliability and particular thermal imaging, like detect the overheating component, that means sometime component will become overheat. So you have to provide the like temperature balancing through AC and other coolant requirement. Same thing, vibration analysis. Vibration also will be important because various mechanical parts are there, mechanical issues are there. That will be the turbines and motors, they may fail. So we have to predict them. So what is the benefit? Reduce the downtime maintenance cost and extend the lifespan of grid component, as well as we have to manage the reliability, as I said, and safety in the grid. So reliability and safety is one of the important part. We can ensure that it will provide the predictive maintenance. We can predict the maintenance is required or not. That is the possible through AI. Load balancing using machine learning. So we have learned machine learning. So we have the particular small base station, macro base station. How the people are using mobile phone and power requirement is every case. So more phones, more power requirement. Power management is very important. So if the power management is not there, so this particular tower will fail. So how this particular states will be identified, sensing data will be given to the neural network. Neural network consists of multiple layers. They are responsible to extract the pattern, extract the feature, based on that predict an action. So change the load condition here. So that local data will force to the whatever the condition will be there. So here AI will help to distribute electricity efficiently across the power grids. Neural network and reinforcement learning, as I said, reinforcement learning means we are predicting whether we are correctly going or not. If it is not going, we can modify with the agent, interacting with the agent. So that learning predict the demand in real time. So AI will manage peak load balancing to prevent the grid may go overloading, or demand response management for optimized consumptions. Benefit, energy cost saving, reduce the power losses, as well as improve the grid stability. We can improve the grid stability, and consumer must satisfy. So consumer satisfaction also one of the requirement. So all this way machine learning will manage the load balancing. Smart grid optimization, as we have seen various renewable energy resources, how grid, macro and smart grid will be designed, how we can optimize them. So smart grid is a modern electricity network. We are using digital technology. Digital technology improve the grid's flexibility, reliability. What is the role of AI? It will modernize the grid system. AI will modernize the grid system. So smart grid optimization, IoT integration, Internet of Things. So I said from the last 10 years, IoT will take part. So entire system will be integrated with internet. And if internet, without power, no use of internet. Every device require internet. In this room, if you are using all things require power. Without power, no devices are working. Okay, so like that, IoT integration means after 10 years without internet, you cannot survive. After 20 years, that means reliance on internet will increase. So we can say AI role in the smart grid optimization, IoT integration. We are collecting real-time data from various sensors, various smart meters. So every home, every house, there are smart meter will be there. And smart meter will collect the energy data. Continuously it will monitor. So in the city, if there are 25 lakhs houses are there, 25 houses, total 25 lakhs meters are there. So 25 lakhs meter will generate the data that means per house, per meter, almost 200, 150 average reading will be generated. So that means how to connect the sensors there and how to collect the data. And data analytics, we have to process the large volume data. So 35 lakhs into 100 GB. So it will become big data. So large volume data from the grid data to identify optimization opportunities. So various optimization algorithms are there. Okay, we have to optimize them. And based on that, self-healing networks. The network may fail anytime, so self-diagnosis activity will be provided to the system for predictive maintenance. So here, automatically we can detect and isolate the faults where fault has occurred to minimize the outage duration. Similarly, energy storage optimization. So as we are using nowadays that means electric vehicle. That is also became very popular. Almost if you'll see the particular people have started to purchase electric vehicles. So that is the growing day by day. So AI ensure that efficient charging, discharging of the battery storage system. So these are the main benefits when we are using AI in terms of smart grid optimizations. It will reduce the transmission lines losses and operational losses, enhance the grid resilience against particular cyber attacks and natural disasters, as well as facilitate the renewable energy integrations and micro grid management. So you can see the smart grid how we are using in particular areas, house, hospitals, industry, various places, how renewable energy resources are also generating power. All these are the factors we can optimize with AI. Now AI for fault detection. So what is the fault detection? Identify the and diagnose the fault in power system. So any device will be there, we have to detect the fault and prevent the major disruption. So AI technique will utilize deep learning, utilize computer vision, utilize rule base. What is computer vision? Analyze the image from the drones to see that anomaly detection or detect the damaged power lines. So somewhere we cannot go. What we will do, will provide the drone camera will sense the line has damage or not by the computer vision, and we have to utilize deep learning. So deep learning identify the whatever the anomalies happened in terms of sensors reading, or we can predict particularly fault locations also, and rule based techniques which are responsible to determine the thresholds for the whatever the threshold of the voltage that will be there, whatever threshold for current will be there or temperature will be there based on the rule based technique, or we can detect the abnormalities, we can detect the faults, and we can diagnose, and self-healing that technique will be applied through the rule based technique. So AI techniques, particularly fault based, related to deep learning, related to computer vision, and related to rule based techniques. These are the main technology we are using. Now what are the benefits? That means it will provide the faster response times, and it will just handle particularly reduce the repair cost also. As I said yesterday, reliability factors are very important and it will go like a bar term. So initial endogenous stage and last wear out failure. In between constant failure will be there. And based on the mathematics, we are going to identify the failure rate of the device. So after the wear out failure, you will not go for repair of the device. Device will be repair not possible. So you can replace the device only. So that means we have to understand, reduce the repair cost. So repair cost will be there under constant failure rate time only. Or initial day, if the device has suffered from some fault or some, we can diagnose them. That is a possible. So likewise, we can prevent the cascading failure. We can prevent the widespread backlog and improve the whatever the grids technique, whatever the grid we are using, improve the overall grid stability and whatever the safety will be required. So reinforcement learning, particularly for grid stability. So as I explained, reinforcement learning is another kind of learning that we are using, particularly for in AI approach, where agent will learn optimal grid control strategy. That means interaction will be there by agent and identify what is the optimal requirement of the grid will be there. So we can provide the control strategies through the trial and error. An application is we can go for voltage control. What is the voltage control will be there? Maintain the grid voltage within the limit, safe limit. We have to maintain the frequency regulations. That means whatever the balances generations and consumption will be there. Basically these are required for avoid the frequency fluctuations and dynamic load management. That means that is very important because we have to understand, we have to adapt what is the power flow will be there. That is the main requirement. So adapting is the one of the mechanism of deep learning. We can adapt as per the whatever data will be generated. So adapt the power flow in real time manner as well as to match the whatever the grid condition we desired. That is the main important part. So similarly, we can see here benefits. So far, we have to reduce the human intervention and provide automation. Mainly we are working for that. That's why we have introduced the AI, we integrated AI and improve the system adaptability. So system must be adaptive. Certain changes will come automatically. System will learn based on the parameter and will integrate into the system, as well as enhance the grid reliance and reduce the downtime. So all this can be done by using of reinforcement learning, and we can make the grid stable. Now renewable energy forecasting. So previous lecture we have learned about whatever the sources are there. So AI role, that model basically predict the what is their solar energy will be there, what is their wind energy production will be there, what is their weather forecasting will be there, and what are the historical data will be available. Based on that we have to predict, forecast it. Similarly, techniques, neural network capture the no-linear relationship between weather and power output. What is the weather? What is the power output? Same time series model. So forecasting future energy generation, how much energy we can generate, that pattern also we can predict by using of time series model based on the historical data. Benefit of renewable energy forecasting, improve the grid stability, same renewable energy integrations. We can integrate the more and more renewable energy integration, as well as reduce the reliance on fossil fuel based on backup power. So we have to avoid the carbon footprint, reduce the carbon footprint, or we have to just reduce the reliance on fossil fuel. Based on this, these are the benefits are there. Energy consumption prediction model, that also we can do with AI. So AI will predict the energy, whatever the smart energy consumptions will be required, consumer energy will be required based on the pattern for better demand planning. So application, smart thermostats, that is the sensors we are using. For appliances, what we are using, optimize the energy based on the AI recommendation. So AI recommend that like a bulb. Now this you'll see what kind of bulb now is inverter bulb coming. You'll see inverter bulb. So the inverter bulb we integrate the AI. That means that integration will provide the this kind of technology. They will recommend how much time they have to just provide the energy, what are the timing will be required to charge, whatever timing this will be discharged. So utility based on AI forecasting for energy pricing and load management, that also we can use it. That is the energy consumption prediction. So how many energy will be consumed, that prediction model also will be developed. AI for power outage detection, that also we can do by using of real-time grid monitoring, by using of geospatial analysis, or by using of customer support. So in real time we can detect the outage, we can predict the potential causes, and geospatial we can map the outage location, we can provide the faster response time. And finally customer support, AI chatbots as we are using nowadays. Now we are not going to call to the customer care like Amazon. There is a one chatbot will be there, just you typing message, one robot will come. The robot will just take your query and will connect to the customer support and then provide the your just support only. So customer report outage and provide real time update also, that will be done by the chatbot. So this is the AI powered outage management we are doing. What is the importance for forecasting in terms of power system? So forecasting basically involve the how predicting of future power demands. In future how much power is required in a particular city. As I said in that session, our system are increasing day by day, our appliances are increasing day by day, so our power requirement also increasing day by day, so that we have to predict. So future power demand and energy productions using historical data we need to work. So that is the main requirement. So benefit, particularly we have to work on grid stability. That means we have to ensure that whatever the balanced demand is there, and we have to supply to avoid the particularly blackouts. Cost optimization, and cost also must reduce because it help to schedule power generation efficiently and reduce the cost. Renewable energy integration. So we have to integrate, mitigate the variability of solar and wind energy trading. So here we have to improve the prices strategies, whatever the energy markets are there, and particularly application point of view, whatever the demand planning, peak load management and energy storage, that must be optimized. These are the main part of forecasting in power system. So time series analysis for power forecasting. What is time series analysis? So a method to determine the trends, to determine the seasonality, and to determine the pattern of data which we have generated through grid. So in this case, these are the trend analysis will be there. We have to understand what is the long term pattern will be there in energy consumptions. What is the pattern of Warangal in particular season? That pattern is common. So based on that, we have to understand the trend. Same, we have to understand the seasonal decomposition. So we can recognize the whatever the recurring pattern will be there based on the seasonal demand spikes. Similarly, we have to understand exponentially smoothing. That means reduce the random fluctuations or for clear patterns. And use case, particularly it is required for daily and seasonal demand forecasting to plan the energy production. So how much energy need to be produced particularly for Warangal urban or particularly for Warangal rural. Similarly for nearby cities. So likewise, these are cyclic, these are trend, these are seasonal. So likewise, this data which we have collected from the last 10 year or historical data, it will be analyzed by time by trends to identify seasonal conditions, to identify the pattern. That is time based data means last 10 year. That is time based data, and that can be solved by machine learning. So in terms of regression, in terms of classification, in terms of predictions. So we can see the regression model for linear forecasting. So model that linearly, like that means interrelationship will be there. So we can say model that relationship between demand and one factor, temperature only. What is the temperature and whatever the demand will be there. Same multiple regressions use several variables. That accuracy, day of the week, time of the year, season, many things are. Polynomial will capture the non-linear relation. It was linear, it was for complex load forecasting. So benefit, we can easily implement, interpret, and what is the short term forecasting. That means related to short term forecasting it effectively for small data set. That means when we are having near term predictions, we can use this one. So we can see that data will be available in terms of mean temperature. This is the data in spring, fall, what is the peak load condition will be there. So based on these models we can utilize. So linear regression will provide the one factor only, temperature. Multiple regression will tell multiple factor, day of the week, day of time or year, or polynomial is complex loop and easy to implement and we can implement. And short term forecasting effectively using for small data set and particularly near term predictions. So this is ARIMA for power demand predictions. So what is this? This is the completely statistical model. Basically this model combining the historical data, trends and past errors also when we are going to forecast. So here auto regressive for particular looking past observation, and I is differentiating or whatever the changes are there in data pattern, and MA is moving average for considering the error terms. So we combine these techniques. So in this technique what we have observed, this is the statistical technique. So component auto regressive. This is the using past values. Whatever the past values are there for future prediction. By past value we are going future, and I integrated value differencing to make the data stationary. We are doing differencing. And third, moving average. We are using the past forecasting error for adjusting. By that way we are adjusting the data. So commonly used short term energy demand forecasting. This is the applications. Benefit, it's very effective for capturing the seasonality and trends in historical power data. So we may get it seasonal data, we may get it trends of historical power data by these techniques. LSTM network, it's a one more popular deep learning architecture basically utilized for time series forecasting. This is the architecture, LSTM, long short term memory. It's a deep learning model designed for capture long term dependency in sequential data. So advantage in terms of power system. It's very helpful in power system because it handles the complex pattern of energy consumptions data. And it's very effective for forecasting or predicting with larger data set and time dependency data, because here it's one memory part will be added. So capture the in any sudden demand change will be there in long term trends. So with respect to renewable energy forecasting, we can forecast renewable energy by using of this network. We can use peak load prediction by this network. We can use real time demand, whatever the real time demand will be there for 2026, 27, that we can utilize. Similar way, machine learning based energy price forecasting. We can do the energy price. Purpose is in future what will be the price of energy will be there. 2030 what will be price will be there. 2035 what will be the. So it help to grid operators for energy markets, technique decision tree classifier, support vector machine classifier, neural network classifier, basically application energy trends optimize, peak or price predictions, and financial planning. So decision tree capture the no linear data between price and influencing factor. SVM classifier will the pricing trends for accurate predictions, and neural network utilize larger data set for high accuracy price forecasting. And particularly application we can identify the energy trend optimizations, peak or price predictions, and financial planning. These all three things we can manage. Now AI in renewable energy forecasting we can utilize like solar and wind, highly variable due to the weather change. They are dependent on weather. So in winter we cannot use solar that much level. So likewise solar energy use the historical data, weather predictions to estimate the solar output. So in summer what will be the solar output will be there, in winter what will be the solar output will be there, in terms of rainy season what will be the solar output will be there, we have to predict. Similar way wind energy, analyze the wind speed. So in winter what will be the turbine output, in summer what will be the turbine output. So hybrid forecasting model will combine AI with the statistical model for high accuracy, and benefits improve the grid stability, optimize the renewable energy integration. So like the same directions we can use the weather predictions for energy management. So we can get the role of weather. Weather is very important because it depends various parameters like temperature, wind, sunlight directly affect the energy demand and renewable output. So AI techniques provide the weather data integrations. We can merge various real-time weather data, particularly for accurate energy forecast, and deep learning model. So deep learning model basically we can learn with respect to data for weather pattern, and also we can predict the extreme condition. There are multiple use cases are there, like forecasting temperature spikes, whatever the data we have collected, and basically it is required to prepare for increased air conditioning use. When you want to use air conditioner, which duration you want to use, how much time you want to use, that you can predict it. So likewise forecasting temperature. So in summer AC is required, in winter AC is not required, in a rainy season AC is not required. Likewise energy demand will change. Similarly benefit, it will help to grid operators to maintain the proactive decisions for the load balancing. So when the load more, when the load will be less, so load balancing for renewable energy planning also very important. So this will be done by the weather predictions through AI in terms of energy management. Now short term versus long term forecasting. Short term forecasting, that means focus on only on daily demand fluctuation, that is short term. Application we can manage real time grid management and renewable energy output adjustment. Long term means we have to predict the demand, that means whatever the energy demand will be there over the months, over the years, like application capacity planning and energy storage investment and policy making. So this is the difference. Short term may rely on real time data and immediate factors, but long term consider the macroeconomic and seasonal trends data. So short term and long term we can see here, these are the labor needs, resource requirement, that is term week months, forecasting long term monthly years. So long term predicts the growth trends capacity, short term predict the resource requirement, how much resource will be required, that is the very important. Now we'll see one case study, AI powered load forecasting in the US. So we can get it, this is the AI technique we use, deep learning and time series analysis. They improve the forecasting by 20%. They reduce the operational cost by optimizing power plant scheduling, enhance the grid stability for predicting the demand surge more accurately. So this case study we can say AI driven load forecasting help particularly for utilize the manage the demand efficiently and they save the cost. That is the main. So in the large US utility, the company they implemented AI based load forecasting model. Another, the solar farm they use for AI for weather forecasting. Location solar farm in Australia, unpredictable weather patterns are there affecting the solar output. So they implemented AI model for forecasting weather and solar conditions. So improve energy output planning accuracy by 25%, reduce the reliance on backup power, optimize solar energy storage and distribution. So AI enable solar forecasting, improve the renewable energy integration and by that way they reduce the cost. So I'll stop here. So any query from participants? Any query, any questions? So tomorrow we'll try to take hands-on part, okay, related to Python and MATLAB. There are certain case studies we are going to apply. Okay, so afternoon session we will go directly in the lab after lunchtime. Any questions, any queries? Sources means renewable energy resources, what we are using. Yes. Yes, we can schedule, that is the main point here. So that standby condition we can manage. Sometimes this resource is not available. We can schedule different resources. So energy can be utilized and provided. So that is the main role of AI. So we just want to know, suppose power is there, then your bulb is working. When power has gone, whatever the energy has consumed, that over. Now your battery, whatever is there in bulb, that is inverter, that will start. So that optimization will be there, how AI can identify, and that means based on that it will provide the particular energy. So 5 or 6 hours we can use standby energy. So suppose that time gone, then it will predict how long it should be charged. That is the main role of the AI. So grid must be identified how long we have to, that means it must be stable. So grid stability is very important. That is one point. More, there are many data is available. For practical purpose you can do research, but mainly in this analysis for the particular renewable energy resources, practical data also in many countries that is available. As I said, case study, especially Denmark, Germany, their reliance, they are improved completely. India also under that, that's why I said in HD goals, already country has assigned certain framework and policies. Like Indian governments have initiated solar, they are providing various kind of funding to work in that directions, and also they are providing to people who want to use, they want to install, they want to integrate solar in their apartment, in their project, they are giving subsidy also. So policy is one of the requirement, by that way only people want to use. So we want to rely on hydropower as well as this wind, but winds having limitation in our country. So we have to go for solar photovoltaic that we are using, and hydrogen also one more factor is there. So we have to integrate that. So AI role is how to forecast the data. So it may be time series data that we have to analyze, and pattern we need to analyze based on the energy need to be generated and based on the demand, and we have to optimize also. Without optimizations, so somewhere that energy is not required. So we have to stop. That backup is there. That is the policy we have to frame. So optimization is one of the factors, and all these things can be done with the help of machine learning, deep learning, and AI. That is the main role of that. So many countries, they have started to work all these systems already established to integrate the AI, integrate the renewable energy system. Okay. Any other questions? So thank you, dear participants. We'll meet tomorrow 10 a.m. same place. Okay. To next part by the sir. Thank you one and all.
Thank you so much, sir, for your insight talk on this today's topic. And I request participants, like tomorrow at same 10 o'clock, we'll start our day 3 session. Thank you one and all.